Portly got a call.
Hello, Paul speaking. Good, thanks yourself. Yeah. We haven't started yet.
I'm just going to.
No, mate, you don't need a special pass. No, I'm not for workforce perspective. I'm across Super Dam. Yeah, for the IP dam. Because Super Dam shouldn't impact the way we do work orders or field requests in any way, shape, or form. That's just the alarming.
Welcome to your meeting room. If you are the meeting host, please enter your PIN followed by the hash key. Otherwise, press hash to join.
As you want way.
You are now entering the meeting. Please wait for the host to join the meeting.
Which is what.
Welcome to your meeting room. If you are the meeting, you are now entering the meeting. You are the only participant in this meeting.
Hello, who just joined?
Yeah, Tony Peruzzi.
You know, Tony. Can you see us as well?
Where am I going to see you?
Are you in a Telstra office or working remotely today?
Remotely.
So how would you... I'm not a Telstra employee, so I'm going to caveat that before I say this, but how would you normally see video on a VMR?
Someone in there would probably run up a link session and we would all share it in some way? Someone on the Telstra network?
Yeah, or if we can do a WebEx, it's on here.
Yeah, okay. I'll see what I can do. It's going to be a bit difficult if I need to draw on a whiteboard today. So we'll try and figure that out as we go.
Just read it. That's what you have to do if you want to overlay.
But
So you do things like that, then make sure that you make sure.
was that one of George's projects?
No, just L3. This stupid. Get into the AN, you can surf, you get all the sites, you can do everything, but it will not give you the email. You will go to the F5 to get the email.
And that Enterprise 6 is token, isn't it?
So, yeah, one of the Wi-Fi, isn't it? No.
Hello,
Good
who
morning,
is this?
it's Ekram here. Ekram Chaudhary.
Hi, nice to hear from you. This is Scott from Cummulus.
Yes, it is for the Cummulus.
Yep.
What's the date? So,
Yeah.
the current trading and will not return to work until. Give George a ring if you need me.
Hey guys.
How you doing? That was silly.
That's going to be difficult.
Maybe easy.
It's a bit hard to do labs once you can. What's this age?
They look different now.
The cat? You look like a refugee. Is this what is it called?
This is Slack.
Oh, Slack. Yeah, it's very nice.
It is very helpful.
So this automatically correlates whoever speaks. I'm missing this video.
Oh yeah, these things are funky. But yeah, it'll try and find who's speaking and give you like a focus view on them.
Hi.
Well, all the other guys are just on the phone. So
The camera automatically aligns. It's not broadcasting anywhere.
no one's joined it to
Oh,
see the video.
perfect.
So.
Only Andy Penn is watching you.
Ah. If Andrew Penn is watching, you have to be a big guy, you know.
It's fucked. I can't even look at the cat. Let's go.
Daniel, have you seen Andy
So
Ping?
she let someone borrow one yesterday.
Oh, okay.
So I'm hoping we can get the same kind of deal.
Email him up.
Yep.
She's the lady who said we can Enterprise 6. We can check out anything.
That's right.
Was that Lucia? Because we joined us as well.
Yeah.
This is the list that we've got there.
Yeah, well, I know you said Lucia.
Anyone heard from them? Might just wait a couple minutes if someone can drop them a text or something.
Oh, Ekram is joining. Yuvan.
Yeah.
Ekram's on the phone, yeah?
Oh, he's
Okay, that's
Yeah,
good.
Ekram is also in the WebEx.
That's very nice.
No, where are you?
We had an email yesterday for how to
Yeah.
connect to
Sorry.
networks and
Connect to the labs?
yeah,
So it's blended.
the internet
Oh,
or
level-
the network or something. Yeah, we received an email from with Emily.
Emily.
Yeah.
Oh, that was using putty
That's
to.
Yeah.
Okay, so that's only going to be a thing if you're connected to mobile EDN. If you hotspot, you can avoid all that stuff to get to labs.
Yeah, level 30. Blended.
I think it has come out.
Yes, it is.
Can I ask you one thing? How do I Telstra RNC to my email? No, RNC to my email. Because I don't have email access. This is my private laptop. So I'm just wondering.
Oh,
My email
that's
as well.
a hard one. Connect to like
Yeah.
RNA in and then.
Oh,
Okay, hang on. Let me
You should be able to just log into
can you send it to
Office
my
online.
personal email?
Yeah.
Still
just give me one sec.
Because
internet network.
it's really not
Yeah,
easy, you
webmail.
know. Like,
We need to have access to our email.
I've sent the lab details, the content,
oh, that's
download
me.
links, all that stuff to
Send
your
it to our
Telstra email.
private one.
We can do that right now.
It's no good because none of us have any.
Is the Wi-Fi?
I'll give my email address.
Yeah,
I was just thinking, well, we might have to.
this is you, right?
Yeah, that's me, correct, sir.
Yeah.
Actually, that's my office email. I don't have
Let's
access
see
to
if
it.
what
Tech
email
Sabarish.
Oh, hang on. Change.
She's got a link
TECH
to mobile EDN to
SABA
you can't download it.
RISH @gmail.com. Thank you very much.
Does anyone else want this sent to their personal email?
Do we really inconvenient?
Sure.
Do we really need it? Only if it's really inconvenient.
Well, I don't,
Oh, Lucia's messaged me.
John? I don't know.
So that's John.fan.
PHAM?
Ah, yep.
Yep.
.87 at hotmail.com.
Ask if he's in competition with George.
Anyone else?
Nice.
Legit. No, Majid. MRZ. At the end.
Ah, you might as well send it to me.
Oh, everyone's getting email spam.
Do we need it or not?
So it's going to have your unique workbench, your unique lab,
So just-
login details, and the download link for all the content. I'll put it on the screen for you anyway. It'll work.
Alrighty.
How far away was Lucia?
Oh, he didn't say. He said he's still driving now, so it's gonna be a while.
We're just going to start. We are just going to start. Okay, let me share my screen on the WebEx. So everyone who's on the phone, have you received the WebEx link? Who's on the phone but not on the VMR with screen sharing, to be precise.
Yeah, we're on.
Cool.
Free time to it, but
And can you see my screen now?
Shakra.
Okay, thanks everyone. Do we still have Yvonne on the phone? I think she joined the WebEx audio. Someone able to?
Yeah, I'll do it.
Thank you. Ekram, can you still hear us?
Well, I can hear you using the phone, but not the computer.
Okay, no, that's expected. I was told everyone would be in the Telstra office and would be able to VMR in and sort of just see us.
That's fine.
Look, Enterprise 6 works as well, right?
You believe them.
I'm sure it has. You can't download the user guide to set up, so keep playing.
Okay. Let's just get started. And we're already doing better than yesterday. We're starting 20 minutes earlier than the other group, so well done. So welcome to the Cummulus Linux Bootcamp. We'll go into more about what we'll cover today, but just sort of some basic expectations on some things that we're expecting you to have before you sort of undertake this training. Basic understanding of Linux. And by that, can you change directory? Can you view a file? Can you move a file? Just sort of basic operator getting around edit type actions. Can you do that? As well as networking concepts. We're not going to be teaching what's a MAC, what's an IP, what's the difference between routing, switching, basic spanning tree, basic routing, all that kind of stuff. That's the fundamental knowledge that this is geared towards. If you don't have that, it's not a problem. But please do let me know if you want to spend more time on something or need to go back on something. We've got a small group today, so we can definitely cater to everyone, whatever level they're at. Hi, my name's Scott Laffer. I am a senior consulting engineer with Cummulus Networks. My background is all Cisco-based. Before joining Cummulus about 3.5 years ago, I was at Cisco in the TAC in Sydney. I was in the data center switching team and spent some time in BU escalation as well with Cisco. Have done everything from Catalyst right through to Nexus 9K, ACI, UCS, and all those kind of things, but really made my mark and was good at Nexus 7K, 3K, 9K, platform level networking, stuff like that. That was what I really did. Before that, I was a network admin at a independent school system in Sydney. I don't know if anyone is from Sydney, or we are. I was at the King's School and ran their network for them on their campus, as well as all their properties. One of the things I love doing at Cummulus is networking automation. Specifically here at Telstra, I am the person that's helped them implement Cummulus technologies for the NFVI project. That's part of Networking 2020. Right now we're at 6 sites, 5 of which are production, all using Cummulus-based switches for spine and leaf networking. What I might do is start here in the room, just get you guys to intro yourselves, give me a bit of background, and really help me gauge where we go with this course and the stories that we tell and the things that I'll highlight. John?
I'm John Cram, technical specialist at Telstra. We maintain precious internal network and here's our network. Cisco certified, and we did a bit of Red Hat.
Mm-hmm.
So we have some understanding of Linux.
Yeah.
So we know how routing and switching.
Yeah. Awesome.
Pretty much same as John. Same certificates, Juniper, Cisco, W5 and Linux.
Do you know everyone on the call?
Yeah, Ikram, working with Ikram.
Yeah.
I
Okay,
don't-
cool.
Over communication.
I just, yeah,
Yeah, we are on the same team.
Syndicate.
Yeah.
right, okay.
Also working with Ikram.
I know.
W3.
Just, you didn't say your name.
My name is Majid. Yeah. Majid Marozi. Yeah.
Easy.
So Daniel, work for these guys, same deal.
Any other unique background information?
Not really.
A lot of the guys yesterday are like, I've been at Tulsa for 12 years, 15 years.
I've
Is that the case for a lot of you guys as well?
I've done 11 years hard time at Telstra, and
Hard labour.
yeah,
Cool.
lots of Cisco, Juniper.
Yep.
Paul Ivey, one of the tech leads for IP Networks. Work for these guys, do the aggregation network. He come from Access Products originally. Do Telstra 18 years.
Whee. You're winning so far.
Hi, my name is Sabah, and I work for IP Networks, same team. And similar Cisco certification, Juniper, and I used to work in network operation, and Telstra is still further bigger and large networks.
Sure.
So kind of enjoying it. Yeah.
Cool. Can I get the remotes just to say hi as well?
Hi, Shekram Chaudhary here. We are basically the level 3 for all the other guys were sitting in front of you. We work maintain the external network customer, data center operation stuff.
Cool. Yvonne, I think you're also on the phone. Hopefully.
Yeah, it's Yvonne here. So me and Ekram and Tony and Dio works in the same team. So yeah.
Cool. David, I'll throw you under the bus next.
Yeah, in Telstra for 19 years, working the external network teams. Routing, switching, load balancing, yeah, pretty much all of it.
Which office are you in at the moment?
I'm in 231 Elizabeth,
Okay.
to Sydney.
Yeah. Cool. Have we got anyone else on the phone that hasn't said hi?
Yeah, Tony.
Yeah, I'll get Tony.
G'day. Been Telstra 35 years, IT about 25 years. So I know all the old school type routing, switching, load balancing as well, but not really exposed to any of the new virtual type stuff. So this will be something different.
Yeah, no. So 35 years, you said?
Yeah. I know you're probably not that old. But
well, I'm not. So you're a telecom employee then?
Yeah, I missed out on BMG just.
Cool. Well, great to meet you guys. Let's get underway. Let's get into some tech content. First things first, all the materials that we're going through today are available for you to download, including the lab guide, all the slides, all that stuff. This is the link. Was emailed to you about 4 times this morning. Sorry. And what I'd recommend is when you do click on this link, the password is there on the screen, Cummulus@Telstra. Download it as a zip and then extract it. And we'll see why later on when we get to get to the labs themselves. Today it is sort of 60-40, 50-50 theory and lab. And we'll sort of break it up based on how you guys are going, where you want to apply your time. In saying that, the labs will be available for you for the next week. And at any point you can go build your own lab completely for free, or have a lab hosted by Cummulus for you completely for free that gives you the same topology and can run through the lab guide at any point. So obviously we do have a lot of content to cover today. The morning session, we're going to talk about what is Cummulus Linux, how does it work, and also why did it come to be. Then we'll do initial setup, how to install, basic host naming, NTP type stuff. Then we'll get into the thick of the networking stuff after some caffeine. Interface configuration, IP addresses, switching, trunk access port, spanning tree, all that kind of stuff. And finish, go to lunch just after we've covered MLAG or BPC or any one of those terms that you want to use. The afternoon we'll cover routing protocols and talk specifically about some of the design choices that have been made for this project, the NFBI project, and configure that. Then we're going to look at automation. We're actually going to take what we've learned and applied and start automating your lab to a full-size spine length network. Then we're going to do some troubleshooting. It's nice and boring, but we've definitely got to get done. And we'll look at some of the ways that Cummulus is creating tools to really help operations teams and effective troubleshooting of networks. Last thing of the day is typically upgrades and things like that. We'll try and breeze through that really quickly. The one thing that's not on here that I do tend to want to cover with you guys, because we have implemented it, is VXLAN. So we'll try and cover VXLAN if we get to it today. That's the last thing of the day. Any questions?
With the spine leaf topology,
Yep.
doesn't that remove spanning tree?
Yes.
The one thing that leaves. So we're still confusing it, just in case someone finds a cable into it.
Correct. So this course is generalized to give you guys operational familiarity to do anything on Cummulus. So like, while we can teach you exactly how it's deployed here, you know, it's not going to give you all the skills you'd ever want for any Cummulus deployment. And that's kind of what we're coming into this as, you know, get you guys familiar with Cummulus so you can get design awareness later. Cool.
Hey, Scott, I was trying to download the thing and it is asking for a username password.
It should definitely not be asking you for a username. It should just be asking you for a password. That password is in the email that was sent to you.
Yeah, I got to that screen, like it takes me to that whole files, but it says if you want to download, then log in. So that's what it says.
Up at the top.
Yeah. So do I have to create my username password to log in or what?
Can you just scroll up to the top of this? Oh, do you mind?
Ekram, is it downloading? Because I've got that screen, but it's still downloading it.
Yeah, so under that login, so under the login sign up in the top right, you see a download button. It's sometimes hidden by like a green bar that was across there trying to give you a pop-up. Oh. And it looks like it starts downloading anyway. So if you just click the download, you don't need to log in or sign up. Just click download, and it should start giving you a zip. Where the red ball can is, please.
Oh, okay.
Everyone, Emily, everyone.
Hello.
Hi. How does the Enterprise 6 work?
I sent you the instructions.
Yeah, no, I can't open it.
Oh, because there's no Wi-Fi.
Yeah.
Are you able to hotspot off your phone?
I can, but I really don't want to.
Yeah, well.
Use this. There you go.
Yeah.
With EDM.
That'll do for me.
Yeah. There's another one up there. We can have 2 people connected to EDM. So.
How many guys do we have on the call?
We have everyone
Just
here
David?
except Lucia. So Yvonne, Ekram, Tony are all on the call.
Lucia's on his way still.
Lucia's
Oh,
on
okay,
his way.
right. Okay. Well,
These guys are much more punctual than yesterday's group. So.
Oh, really?
Yeah.
Expect you, George.
I didn't sleep yesterday night. No, just kidding.
Yeah, just let me know if you need anything else. Okay.
All right. So has everyone got the course content?
Yeah.
We're good to go to that. Okay. Where did those 2 go?
One went to the toilet, I believe.
You're saying about
One
function?
went to get Lucio.
One right to the chair. Sorry to be late.
That's all right. I'm Scott. We're going to continue here, but we can set you up with the course content in a little bit. Okay, view, full screen. All right, let's get into it. Let's look at Cummulus Linux itself. So, who's heard of Cummulus before today or before a couple of months ago? Sweet. Good stuff. So, I'm going to tell it as a bit of a story. I've always kind of found that's the best way to tell why Cummulus came about and why we exist in the market today. So one of our founders, there are 2 of them, is a guy called J.R. Rivers. He was at Cisco. I used to run the Catalyst 3K business unit, very well established chip designer, software designer, all those kind of things. Then moved to UCS project. He was the chief architect for Cisco's UCS. And after that, Google came asking. They've basically seen at Google, they want to build their own network. They see that Cisco, Arista, Juniper, and all those big networking players, all of their data center switches have the same things inside. They have the same Broadcom ASIC. There is no differentiator in the hardware. The hardware performance was identical. And they weren't particularly happy with any of those software choices that they had. So they said to JR, we want to build our own network. We can go buy the hardware. We've got more than enough buying power and the expertise in-house to design our own switch and use the same ASIC and get that same performance. We want to control the software that we have, and we want to use it for our specific purpose. So he went off to Google for a little while, helped them build their own network, and while he was there, he was like, well, 20 years ago with servers, we kind of saw this same change. 20 years ago, you had an IBM mainframe with AIX, and that was a vertically integrated locked-in stack. You had a Sun server, and you had to run Solaris. And back in those days, the differentiator was in the hardware. You would get different performance from their CPU types and all of their hardware innovations. And because of their unique hardware, you had to run their software. But 15 years ago, we saw the x86 processor come out. So Dell started making servers with the x86. HP started making them with x86. And they never had to have a software offering. We see software vendors come to the market, be they like Red Hat, be they VMware, they don't now have to have a hardware offering. So we've seen this big disaggregation within the server world that enabled people to, choose the hardware that they wanted and, fight hardware vendors off against each other for the best price. And likewise with software, they got to choose the software that was the best choice for their use case. And again, battle software vendors off against each other in order to get the best price. It's like, well, networking's very much the same now. We've got everything in data center switching uses these Broadcom ASICs. The hardware performance and routing switching performance is the same between Cisco, Juniper, Arista, Dell. Why can't the industry now have their own software choice? And that is why he started Cummulus Networks. He came up with the idea that, okay, just like servers, we want to be able to install our own OS onto a switch. And that was where it all started. And now there are multiple OS choices, and we'll talk about how all those OSs get on. But the direction after making that innovation of being able to install the OS, the direction that we took Cummulus is that we want to make it simple for this to be deployed and managed at scale, taking all those principles that he learned at Google and how they manage thousands and tens of thousands and hundreds of thousands of endpoints and apply that to the networking stack as well. The first way that he did that is in these web scale players, I've got 42 RU of servers running Linux. And at the top, I've got 2 RU of things running weird software that a specialized team has to know that doesn't use the same tooling and has, a very locked down purpose. Why do those 2 RU have to be any different? The first thing that we did is we used Linux as the whole data center operating system. And now it doesn't matter whether you're on a server, you're on a storage device, or you're on a networking device, Linux is the operating system that you're using. The interaction is the same, the tooling is the same. You no longer have specialized tooling and different workflows just to interact with networking. One of the other things that obviously we see is that Google doesn't have one engineer per 100 devices. They have one engineer per 100,000. And they do that because they have automation. And Linux is ideal for automation. It enables them to reduce, obviously, cost, but it scales really well, and it means there are fewer and fewer errors that they make. The other thing that they do in those web scale data centers is use a lot of layer 3. Layer 3 is typically hard to configure. There's a lot of things you need to think about. So simplifying the configuration of existing protocols is something that they do. And of course, what they do is a lot of simulation as well. Us as a software vendor, we don't design or make any hardware. we'd be pretty average if we couldn't simulate networks as well. And so what a lot of things to do is you have a simulated network where you do your change validation first before you ever push it to production. And so that's the general mindset of why Cummulus exists. We see that these web scale companies have the right operational approach, and now that those technologies, those methodologies shouldn't just be exclusive to those people. It makes sense for everyone in enterprise as well. Enterprise service provider, education, it makes sense for everyone, and it's achievable. That tells my story. So that's the sales side of things over. Sorry, it's kind of obligatory when you do a boot camp like this. What we have on the screen right now is kind of a comparison of that locked-in system versus that open system. If you look at an incumbent vendor, when I say incumbent for the rest of the day, I do mean a Cisco, Juniper, or Arista type offering. They're that one block solution. They give you the hardware, they mandate you run this software, and their own applications are on top. Their BGP stack, their monitoring stack, all those kind of things. Vendor locked, no change, can't do anything about it. Where the rest of the industry, regardless of the technology that's underneath, it's compute, storage, or networking, you now have your choice of hardware, your choice of OS, and depending on the OS that you choose, you have the choice of applications that you run on top. You can pick your own routing stack, you can pick your monitoring tool, you can pick your automation tool. It's all there and available for you to choose to get the most out of it. Cummulus runs on, this slide is a little bit dated. Right now we run on 94 shipping systems from 10 different vendors. At Telstra, they have chosen Dell switches, but we do run on 10 different vendors, and that is everything from 1 gig with PoE, we've got a UPoE switch, everything to 100 gig, 32 by 100 gig 1AU switches. We have 200 gig switches sort of due out in 6 months' time, and then 400 gig in about 12 months' time. We do have a chassis as well, a few chassis, but we won't talk about them today. We don't support every open networking switch. We are geared towards data center. That's our bread and butter. So we don't support some 24 port switches and some other different use cases where open networking switches exist. So what you see on our hardware compatibility list at cumulusnetworks.com/HCL is what we support, the version that it's supported from, and just jump on there and have a look if you're interested. So with us being Linux and with us thinking about opening up the networking industry to take advantage of some of those things, we are an open source company as much as we possibly can be. And we'll talk about in a couple of slides' time what is not open source with Cummulus. Like we mentioned, Cummulus pioneered the technology to install an OS on a switch, install a third-party OS on a switch. It's called the Open Networking Install Environment, or ONI. If you want to change the industry, though, you can't keep that to yourself. That paradigm shift only appears if you have multiple software vendors giving customers multiple choice. So we gave that technology away for free. It's now managed by the Linux Foundation. And so now anyone can come in, make an OS, anyone can come in and make a switch that can have an OS installed on it because that technology is open and free. We obviously work quite heavily with the Linux community, whether it's packages that we create ourselves and are pushed upstream. One of those examples is IF Uptown 2. It's our interfaces manager, and it will be part of Debian moving forward. It's already been on the repos for about 4 years, but it will be the standard interface manager for Debian. We also invented VRF to the Linux kernel. So that is now available on servers and is used as a part of server-based SDN technologies. We use an open source routing suite that started as Quagga. We now have a fork of that's geared to data center grade and service provider grade features, which is free range routing. That's all open source. Lots of companies contribute to that, and everyone benefits from lots of people contributing to that. Back in the early days of open networking, it generally took a little while to port to a particular switch. every single hardware vendor would say, my LEDs are here, my fans are here, and these are how you control them, and that would be very different hardware vendor to hardware vendor, platform to platform. But if you think about the server world, you don't really have those kind of problems. You just say, here's my server, here's my OS, and it just sort of kind of works together. And the technology that enabled that is something called ACPI in the server world, and that is basically a standardized way of saying, here's my OS, I'm going to read this register, and now I know my fans are here, my LEDs are here, and all that kind of stuff. There's no custom code and custom drivers to make that work. It's all a standard, so these guys can port to a new hardware system very, very quickly. That now exists for networking as well, and so we can bring on a new switch that supports Cummulus Linux in a couple of weeks now. All right, let's talk about the three things that Cummulus has to offer. The first is Cummulus Linux. This is our bread and butter. This is where we make all of our money. And it's what Telstra has bought. It's Cummulus Linux. This is our operating system that we install onto switches, or you guys install onto switches, and we give you a license key for. I mentioned earlier that we don't sell or design hardware. We definitely don't design hardware, but for first purchases, it's kind of a bit daunting to go to this paradigm shift and say, I need to buy my hardware and my software differently from networking. A lot of people don't have those procurement channels. So what we do is we do offer some hardware, rebadged edge core hardware, which we call Cummulus Express, which you can buy to basically get going straight away rather than having to do those two separate purchases. Good for an initial try, lab type stuff. If you want to buy more, obviously you can, but it's sort of just there for one-off, onesie, trysie, twosies type thing. We do have a specialized platform called the Cummulus RMP or Rack Management Platform. It's a really, really cheap switch, and on the OS we install some basic things like web servers, IPMI tools, DHCP server, things like that, and it becomes a great out-of-band management switch that can do all those IPMI, Pixie type functions for servers rather than having it on a centralized server. It's kind of an all-in-one box because we're just Linux.
Okay. So we can buy a Cisco or Juniper router or switch, then we use the Linux OS.
Not quite yet. So
what hardware you mean when you can buy hardware? Any hardware and then
not any hardware. It has to be an open networking switch. Juniper and Cisco and those guys don't make open networking switches just yet. It's not to say they're not capable of it. They certainly are. And from my time at Cisco, I definitely saw them make those products and try and sell it to those web scale type companies. But right now, for main market, they don't support this.
Is open networking and open flow same switch?
No.
Different?
Open flow is a different concept, and we'll talk about that later in the day if that's okay.
So for this instance, it's the hardware is Dell.
In Telstra, it's Dell hardware. We're using Dell Z9100 switches, which are 32 by 100 gig 1RU boxes. In the main network and in the management network, we've got some 48 by 1 gig and 48 by 25 gig switches as well. But hypothetically, you could replace that with HP or someone direct from China. There's 10 vendors, like I said, that all have the same performance in hardware, and you can keep that same consistency with Cummulus Linux. Now that we have a shipping OS that is Linux, we're starting to think about tools that network administrators would want that were not, sort of previously possible because of the lockdown nature of the operating systems. And the first one is Cummulus NetQ. It's a telemetry and monitoring system for networking designed around network operators. And we'll play with that this afternoon. I think it's stupidly cool. The other thing that we do sell is that our packages on our OS also work on servers. So our routing daemon that we support, you can also put onto a server. And there's some really interesting network technologies where you can get rid of layer 2 entirely, route from the server to the top of rack, to the spine, and then back to the other server. You can go completely layer 3, server to server. You can do that completely for free as well. You just take the package, install it, and away you go. But if you wanted commercial support for it, we sell that as well. Cool. Any questions about that? Otherwise, we'll get right into the architecture slides. Slide the, it's one. Okay, so one of the things that's talked about in the industry, especially by the incumbents, is they use Linux or they're Linux-like. The difference with Cummulus is we are just Linux. Those sort of incumbent vendors, they use Linux because it gives them hyper-threading and memory management and all that kind of stuff, but they're not using Linux as the platform itself to do the networking. They're running their own proprietary applications on Linux to achieve networking rather than using Linux to do the networking. We are a native Linux distribution, so we are a fork of Debian, basically. We take out all the heavyweight server stuff from Debian, put some networking performance improvements in there, and that's basically the basis of our distribution. This is the architecture slide, and we'll take some time looking at this one. If we look at the top light grey box, this is exactly what you'd find in a server. You're going to have CPU, RAM, flash, LEDs, fans, all that kind of stuff on your server. And that's just industry standard stuff. So all of these open networking switches are predominantly Intel Atom or Intel Celeron based boxes. They've got a little Intel Celeron SoC, so one of those little chips that has it all in one. And then what they do is they connect the networking ASIC to it via PCIe. So similar to a gaming computer, you've got a gaming computer, it's got a graphics card that does hardware acceleration of graphics. A networking switch is those same components for CPU, RAM, yada, yada, yada. But we now have hardware acceleration of packet forwarding. And that's what that ASIC is used underneath. We have a Linux kernel there. The Linux kernel is the brains of the operation. It has a routing table, it's got a ribbon of fib, it's got a MAC table, it's got an ARP table, it's got ACL tables. It is the brains of the operation there that maintains all that packet forwarding state. In order to interact with the kernel, we have tools in user space. We have routing suites and static route commands. We've got bridging suites and bridging commands. We've got ACLs as well on the top there. Everything you see in this sort of darker green, that's around the Linux kernel, around routing suite, etc., is open source. So we run a 4.2 Linux kernel, or I think it's 4.2 Linux kernel, and that we get directly from upstream. It's it's got some networking tweaks in there as customizable knobs, but it is a standard Linux kernel. Likewise with the routing suite, all that source code is available. Anyone can go and view it. Anyone can go and ask for it, and you can get visibility into the full stack. No, sorry. The way in which you talk from user space into the kernel is also standardized and open. It's a protocol called Netlink. So Netlink has an RFC, and any Linux developer in the world would say, well, if I want to make a networking program action to the kernel, I need to send a Netlink message. So if I create a static route in user space, I'm doing, IP route prefix destination, or next hop, sorry. That sends a Netlink message into the kernel. The kernel accepts it and puts it into its routing table. Where Cummulus comes in is on the right side. We have switch D. This is the only closed source part of Cummulus, and we'll talk about why that is in a second. What switch D does is it monitors those Netlink messages. So if it sees a static route going down into the kernel, it then programs the hardware with that same static route. If it sees a new ACL put in, we're going to put that ACL in hardware because we're monitoring that Netlink message that goes down into the hardware. Does that make sense? Can anyone think of a situation where the ASIC would need to tell the kernel something? So we've talked about the top down, what about the bottom up? Is there a reason for it? And if so, what would it be?
Link status, withdrawal of routes.
Withdrawal of routes is definitely top down, but Link status, 100% agree. Anyone else got another thought? Okay. Counters, that's a big one as well. Counters need to go back up the other way. The other thing that most people don't think of is learning a MAC address. MAC addresses, that MAC address learning functionality is always done in hardware. And that needs to get pushed back up. Link state's always the big one that people pick up on. That's a good answer. Any questions on the architecture? It's quite simple. Sorry, it's not quite simple. It's one slide that we sort of talk through. We don't have multiple slides. Cool. I just want to compare and contrast that to the incumbents and what they do. So their hardware is the same. They're still using those Intel chips. They're still attaching the same ASIC via PCIe. The difference is that they may even have Linux on there. The difference is it's all proprietary applications, all proprietary inter-process communications, proprietary drivers. So, to take a Cisco example, they're going to have their proprietary BGP stack talking to their proprietary RIB. That proprietary RIB will use proprietary inter-process communication to talk to their proprietary driver, to talk to the standard hardware. There's about 50 people in the world that really understand that, and they're all based in San Jose, California. As opposed to this mechanism, there are tens of thousands of people around the world that understand this methodology. There are thousands of people working on it every day to improve it, not just purely for networking, but for all elements of Linux technologies.
It's open source.
It's completely open source, except for switchd. So in those boxes on the right, switchd is closed source. It would be open source if we had our choice, but the ASIC vendors have SDKs and APIs, and we are not allowed to expose them. We cannot expose to an end user how those things work, basically because they've got billions of dollars on it, and that's how they license it. To develop an ASIC, when I was at Cisco, it cost them $2 billion to develop the F3 and F4 ASICs for the Nexus 7K line cards. That was the cost all in. It was about $2 billion in 5 years. So obviously there's a lot of money riding on this kind of stuff, and there are a lot of ASIC vendors competing to keep at the forefront of it. So right now, that is closed source. We can't expose that purely because of the licensing, and we will get screwed if we ever do. And so that's the only closed source part. Everything else is completely open, very well understood, and it's all aimed at giving you guys choice on how you want to use it.
Hey, have you heard of software-defined network?
I have.
Yeah, it's very similar. As in the Linux spine node and everything's being automated.
Yeah, software-defined networking is an interesting term, and we'll talk about OpenFlow now if that's cool. It's kind of like saying, what is cloud? Yeah. It's one of those terms that, depending on who you are, has different meaning. SDN, from my perspective, so Cummulus is not SDN from Cummulus' perspective, and from other people's perspective as well. It's a smarter way of doing the networking that we already know. So we're not going to do anything funky. We're not going to introduce a controller. We're not going to use proprietary flow technologies like OpenFlow. OpenFlow is open source, but we're not going to use sort of flow-based technologies. We're taking those well-established, well-known networking concepts and applying them in a smarter way to make them really scalable and really easy to manage. SDN is controller-based, sort of limited functionality for a specific purpose. Like networks based on OpenFlow and those controller-based technologies for pure networking, like switch-based networking, really didn't take off. Some education networks did it, some service providers did it in sort of limited capacities, but that whole networking controller technology really is still yet to kickstart. And that's sort of my interpretation of SDN. Controller-based, using not necessarily standard technologies under the hood. And OpenFlow definitely fits in there for me, where, like I said, Cummulus is the same stuff we know, just done a bit smarter. Cool. Questions on architecture?
Cummulus hardware can be controlled by SDN, like netconf, and can be.
Not netconf just yet. So we'll talk about the automation tools that we can use later. But from things like NSX, you can definitely control Cumulus if you want to. It's not very common, but it definitely works. Same thing from OpenStack. You can use OpenStack to control Cumulus for bridging functions and things like that. But it's not as prevalent as you might think. But the functionality definitely exists, and because we're Linux, people can just integrate that on very, very easily.
Yeah.
Cool. Let's move on to initial setup. Okay. So what we're going to do here is look at how do we install an OS onto an open networking switch. Then we're going to make sure you guys have got access to lab, basic look at licensing, and things like that. Okay, so we talked about ONI very, very early on. The thing that makes a switch an open networking switch is the presence of ONI. So ONI is kind of like Pixie on a server, as well as so if you look at Pixie, it's sort of a 40-year-old technology. It uses very antiquated tools, DHCP, TFTP, and it's quite limited in the functionality that it has. And when we started to transition this market, we had the opportunity to rewrite it with some new functionality and new smarts and new logic. So ONI is very much an install environment, sort of geared for the 21st century. Like I mentioned, the thing that makes a switch an open networking switch is the presence of ONI. It's normally installed on a separate small bit of flash in the box, or it's in a dedicated partition on the drive inside the switch. So most of these switches have flash memory, 8 gig or more. Some of them have a little small partition that has this environment there, but it is an install environment that enables you to put a fully fledged operating system onto the box, just like we do with Pixie on a server, just a bit smarter. First thing we need to do when we want to install it is obviously go download the particular image that we want. This is all at cumulusnetworks.com/downloads. We support 2 different ASIC vendors and 3 different CPU types. From the ASIC vendors perspective, we have the Broadcom. 9 of our 10 hardware vendors use Broadcom ASICs under the hood. Mellanox is the other choice, and Mellanox sell their own switches with their own ASIC inside. They don't play nicely for each other. Remember, the ASIC industry is very costly, and these guys are fighting a very big war right now to say who has the best ASIC. So they don't play nicely, so they're in separate images. Likewise, different CPU architectures have different requirements. So we have x86, ARM v7, and PowerPC. You won't see any PowerPC switches anymore. They're all gone out the door. All the Dell switches are x86. 95% of these switches are x86. So every time here, you're going to go get the Broadcom image for x86 CPUs. Okay, so ONI has a very, very smart and redundant way of trying to find an OS. The first thing it's going to go do is look locally on the box, do I have an OS? If I don't see one there, I'm going to go look at all the USBs that are plugged into me. I'm going to go see, do I have a USB in here? Mount it, look for an OS, not there. Okay. Last place we go check is over the network. And we're going to go search a range of different places on the network for an image. And that image name that we're looking for is something called ONI-installer. That's the file name that we're looking for on the local disk, on the USB, or over the network. What we're going to talk about is an over the network model first. What we need for this bare metal switch, obviously, we need our installation image. We're going to use a DHCP server, and we're going to need a web server. So very first thing that ONI does when it comes up is it tries to get an IP address for the management port on the switch, the ETH0 interface. So that's plugged in. It's going to go out, get a DHCP lease. From that, within that lease, we're going to have a DHCP option. That option is going to be 114, as for reference, and it's going to give you a URL where your image exists. We get that URL, go, thank you very much, download it from the web server, and install it on the box. This is DHCPD is a DHCP package for Linux, a DHCP server package, and this is just what the config would look like. You can see the URL there that we're providing. Okay. On that web server itself, we're just going to put the image in the web root. So if we went to 172.16.01 in our web browser, we're going to see these two files there. Remember, we're looking for that oni-installer name, okay? And what we're going to do is just create a shortcut or a symbolic link in Linux terms to that name of the image. So if we got a new image, we'd simply update that link to point to the new version. Okay, so that name is always there. And this methodology is the same whether you're installing Cummulus Linux or any one of the other OSs that are available for purchase now. Big Switch, IP Infusion, Picker 8, other guys like that. Okay, one thing I'm just going to show very, very quickly. We talked at the start of this section, there are specific images for specific switch configurations. Broadcom, Mellanox, yada, yada, yada. What happens if you had dual sourced your environment? You had some Mellanox switches, some Broadcom switches. So we talked about the waterfall model of how it searches different locations. We're now going to show you what it looks like within each of those locations. So if I jump onto the net, jump onto the ONI website, about documentation, and image discovery and execution. So what we do in each of those locations, local disk, USB, network, is we look for something more specific than oni-installer. We look for first oni-installer dash, I need to reference this, the CPU architecture dash the vendor underscore the machine dash the revision of the machine. So in this case, we're going to go look for these Telstra switches, oni-installer dash x8664 dash Dell EMC underscore Z9100 dash R0. If we can't find that, we're then going to go take the last thing off. We're going to look for x86 Dell Z9100, x86 Dell, x86, and we're gradually going to go until we find the best match possible. Just like routing, it's the longest prefix match, but for the operating system name. And that's how we can basically set this up to have different images for different switches. If you had just only installer and you tried to use the Broadcom image there, you're going to go pick up the Broadcom image and potentially try and install on a Mellanox switch, which won't work. So, for multiple environments, or if you had different versioning, you can really get quite granular to have this automatically happen. So, back to the slide deck. At no point here have we touched anything on the switch. You get one of these things out of the box. This process happens automatically. So, what we will do here, or what we do here, and what is usual is that plug it in, no touch, Cummulus is installed without you having to do anything at all. Okay. Let's look at some of the initial config that we need to do on a box once the OS is installed. Now we're going to look at it manually now, manual steps that we're going to do. We do automate this completely in the afternoon session as well. So we're talking about no touch installation, no touch provisioning, just plug it in, let it go, but we need to look at the manual steps first and what you want to do. On the box, we've got a console port like you'd expect. It's not 9600 for the baud rate, it's 115200. That is the open networking standard port. But it's 8 none, 1 none, just like any other device. And we have a management port. To us, that is called ETH0. Other vendors call it management 0 or things like that. But for us, it's ETH0. To get into the box, you can obviously come in via console. We have SSH on the box by default as well. We use the standard Linux Open SSH package, no telnet. Okay. We've got 2 user accounts on the box by default. The first one is Cummulus. It's a normal user, but it's got super user capabilities. It can get in via SSH and console. The default password for Cummulus is Cummulus with a capital C, links with a capital L, exclamation mark. That's a pain in the ass to type, so that you change it. Okay? I still get it wrong, and I've been typing that 20 times a day for 4 years. So, do change it, and that's why it's written like that. So you change it. I also have a root account. Root is root. You guys have all done the Red Hat training now. You can't get into that by default. It doesn't have a password set or anything like that. But obviously, it's Linux. You can just change that. And for automation purposes, sometimes you will. So the first thing we'll do when we have installed Cummulus is we're going to install the license. Once we've done that, we're going to configure that management port. Like I said, it's DHCP by default, but you may want a static IP or something like that. And we're going to go through and configure the basics: host name, NTP, DNS, stuff like that. So Cummulus Linux does have a license. One license gets you everything on the box. What that license does is turns on the front panel ports. We don't have separate licenses for increased speed. We don't have a separate license for overlay features or advanced routing. One license, you've got access to the full box forever. The other thing that will get you is 24/7 support to our support organization, what Cisco called TAC, we called GSS. It's Global Support Services. That's where I came from in Cummulus. That was my first job here, was to start that team in Australia. And they're 24/7 worldwide. There are 3 different license types. There's a 1 gig. So if the predominant port count is 48 by 1 gig, that's a 1 gig license. If the predominant port count is 10 gig or 25 gig, we call that a leaf license. And by predominant ports, like if it's got 10 gig ports and then like 6 40 gig ports, that's a leaf. Okay. The spine license is for your 32 by 40 or 32 by 100 gig switches. And that's a spine license. There are some vendors that have a 16 port by 100 gig switch, sort of a half width. They're pretty cool. And that's still a spine license, but it's discounted because you only get half the ports. So just so you know that's there. What does the license do? It activates the front panel ports. So without a license, you can't go configure those ASIC ports behind the ASIC, and obviously that's what you're spending all your money on. And so that once that license is installed, switchd can then start. Without that, switchd won't start and those ports won't be enabled. How do we install the license? We use the command sudo. I say sudo. I got in trouble very early on at Cummulus for saying sudo. Sudo is super user do. So I don't mind if you say sudo, but I like to give that history lesson. Sudo, super user do. Yeah, well, one of the guys, a couple of the guys used to work with Linus Torvalds, the inventor of Linux, and apparently he was very pedantic about it, so they got very pedantic about it. And they're a bit passionate at times. So you sudo cl license -i, you can then give it a local file. You can point it at a remote URL like the HTTP URL, or you can do cl license -i, hit enter, then paste it in. It's just a key. Once you do that, you do just need to restart switchd, and all those ports will be available for you to use. By default, we have the management interface, the ETH0 interface configured via DHCP. We do have the capability to put an IP address on there. We'll talk about more about these commands and the stuff on the right in the next section. The other thing about Cummulus by default, the ETH0 management port is in the default VRF. What that means is we can route a packet from a front panel port out the management port, or switch a packet out the front panel port from the management port. That connectivity is enabled by default. No one tends to use it anymore, but you do need to enable management VRF if you want to isolate that ETH0 port. And that's definitely something that we do 99.5% of the time. But just be aware, unless you explicitly configure it, that ETH0 port is in the default VRF. That normally causes a problem with a default route, just for why we recommend you put it in the management VRF. if you receive a router option in your DHCP, you get a gateway. That's a default route. If you try and configure a default route in the default VRF, it's already there. It won't go in. So, management VRF. When you do configure this, you get kicked out of the box if you're SSH'd in. Just a heads up. Set a host name, and we're going to do that with NetAdd hostname. Set DNS servers, IPv4 or IPv6. Set a time zone. The beautiful thing about time zones on Cummulus is you tab complete. I could never get them right whenever I did them in any other vendor. You tab complete the time zones. We do give you default NTP servers as well. Pool.ntp.org are just public NTP servers that anyone can sign up for, which is really handy. But most environments like this are airlocked, no internet access, so you want to delete those out of there so it's unnecessary traffic. Any questions about basic setup? Cool. What I want to do now is just get you guys, make sure you've got access to the lab, grab some caffeine, do lab 1 where you install a license. Everyone by now should have received 8 or so emails from education@cumulusnetworks.com. Within that, you have a unique workbench ID. This is the topology that we're starting with today. The topology does get bigger and bigger as we go through and configure more and more features. So within that email, you would have seen a unique workbench ID. In that email, you have workbench16@vx.wb.cumulusnetworks.com. SSH into it using that unique password that is there, and that'll drop you onto the out-of-band management server. It's like a jump host. From there, you can SSH into the devices by host name.
Sorry, how we connect to Workbench?
SSH.
Party using party.
Okay. So if you're on mobile EDN, you don't get direct access out. We've got to put it through a proxy. If you're hotspotting, just follow the instructions exactly. That's all right. Is anyone here using mobile EDN or EDN natively?
I'm connected to the Cummulus network.
I tried.
No good?
Cool.
So, guys, please let me know. Please log into it. Then we'll take 5-10 minute break. Once you get into it, then come back and do lab 1. Okay?
So I've logged into the out-of-band management.
Yep.
That's the management
So,
port.
The out-of-band management server is a jump host.
Yeah. It's
And
like
then from
router.
there, yeah. And then from there, you SSH into LeFO1.
Oh, the terminal server, yes.
So it's not terminal, it's SSH. So if you look at the topology on the screen at the moment, so you're on the out-of-band management server.
Yeah.
Then we've got like a management switch that connects to, and that connects to the ETH0 port of all of those devices. Okay. So give it a go. Have a break. Do lab 1. I'm going to show of hands of who's already in. You're into the out-of-band management server?
Yeah, I'm in.
Anyone else?
No.
Do you want to send me that in?
Yeah. Can I just put on? Are you hotspotting?
Yeah.
So when we download this Cummulus image, when you can't run it in VMware or
you can. So this is actually virtual, and what we talk about at the end of the day is how we virtualize it and how you guys can build your own topologies, build your own labs, and all that kind of stuff.
But I need a license to.
Nope. Completely free.
Wow. I'll download and run it.
All right, where are you on here? Oh, you did it up. So your workbench 27.
You know, why do you use Vagrant? It sounds familiar, but I don't know. It's a Vagrant is a
Vagrant
kind of a
is
Docker.
Vagrant's a VM orchestrator. So what it enables you to do is set up a series of VMs and configure them, and then hand it over as one environment. So, like, say I wanted to give you like a web server, a database server, and an application server, like that sort of 3-tier thing. I would define that in a Vagrant file, give that to you. You start it up, and it creates the VMs and networks them together and orchestrates them together for you. So it's a way of describing like a whole virtual environment and put it together and give it to someone else.
It's like Contrail and Juniper.
Not quite. It's closer to. It's like with Kubernetes.
Oh, Kubernetes. Yeah.
So Kubernetes does something kind of similar for containers. You're able to describe a workflow of containers that you need, and it goes in there and spins up the containers and networks them and orchestrates them together.
Yeah.
Vagrant does the same thing for VMs.
We got the team lab, is that all right?
Sure.
Yeah.
The labs are available for you guys for the next week.
Yeah.
So you guys can do it later as well.
Yeah, we'll do it.
But yeah, no, feel free to do teamwork. Yeah, just don't fight.
Because like this doesn't have party, my mom is always.
Are you guys going to 3-way teamwork?
Yeah, 3-way teamwork.
Oh.
Yeah. 3-way action.
Very close team.
We've got 3-way.
You should be able to get party pretty easy.
Party's
It's 800k or something. Yeah, sometimes, like I know I'm not a Telstra employee and it could be a bit taboo, but I can spend a shit ton of money on this stuff. We can't get you guys the laptops.
Yeah, you can't do laptops at all.
So if you have logged in, feel free to go grab a coffee, do lab 1. Sort of want to get started again at 10:25, 10:30 with the next bit of content just to keep the schedule. Make sure you do caffeinate.
Right, where were we?
So you're on EDN, right?
Yeah.
Okay. You got putty?
Yes.
Okay, so we need to do some funky things to make that work. And I'll run you through it right now.
How do you secure CRT?
I don't know how to set a proxy with secure CRT, that's my problem.
Oh, I may not have putty actually.
So I saw one of the guys, oh no, he was hotspotting yesterday.
Nah, you're a SOE. Just type in putty.
Just
type.
But it's a 64-bit, so it might not be installed.
Should have it
Oh, yeah.
because
putty.exe, yep. Yep. So what we need to do is workbench, whatever your number is, at
That's the email,
That's
I
the
think.
email? back in your email, yeah. So you're looking for something from education@cumulusnetworks.com. Yeah, that's it.
A few of them.
Yeah, sorry. So you want to be
38.
workbench 38 at, so don't copy the domain name. We need to replace that with this IP because that does not resolve within Telstra.
So it's workbench 38.
Workbench 38 at.
I'm downloading a pre-built topology file.
Well, that's him. You guys have got your own unique ones.
Yeah. So,
Are you on EDN or hotspotting?
EDN.
Yeah, so workbench 38 at this IP. And then before you click go, we need to set a proxy as well.
and if you're hotspotting, just
Just go straight to it. Workbench 38 at vx.wb.cumulusnetworks.com. That results in
what?
vx.wb.cumulusnetworks.
And the proxy?
So go proxy in under connection. So first one under connection. HTTP. Yeah, so you've got to select HTTP. In there, put the IP address 1097. Uh, 217.136. And the port is 8080.
The password is Cummulus and Telstra.
No, the password is here for you. And then, yeah, do the click consider proxying localhost connections and click no there, and then chuck your D number and account 01 password there.
D number.
Your D number.
I'll try the C number.
Your C number.
Insult.
TTMD. I'm restarting that service. So
That's it.
And now just go back to session, just so we don't have to type all this crap in. If it was, click, give it a name like Cummulus Lab or something, and then click save.
So what's the port number?
8080, and then click open. Now click yes, and then in that email you've got a password there. Yep, just. So you're now on that jump box, and you can now start lab 1. Go to all the things.
I got the ET80 pass here, and I'm actually continuing this one on ETMCTL.
We need backup.
Get in. Yep. Yep. Can you? Oh no. So
I take it this is
you need
part of
SSH.
the lab instructions.
This is an SSH.
All the pages.
Yep. So jump to putties.
That.
So you're gonna what's your workbench? Okay, so you need workbench 34
email.
at 162, 248,
Use that link.
201 to 11.
But
And then
when you do the download, once you get to that page,
HTTP.
no longer. Hold on. I've got that page there, there's that download.
Make sure you save
Yeah,
the payment type out everything. Yep, so just replace proxy with that IP 10.97.80.
/B
Then
/CL.
consider, click no,
Okay, CLB.
and put your D number and password again.
Nice.
Your C number as well. And then go back to session top, give it a name and save it. And open. And now you've got a password in your email. And that's the password you need.
Yeah, password on the
Like I said, you guys an email.
password is Cummulus. Capital C. And then the download underneath it. And you don't worry about that.
It's dead. Can you just restart it? Cummulus on it.
And then I just like that. If I want to
Oh, I
go,
missed the tab.
There's a PDF. Yeah, that's right. Lab number 1.
Oh, yeah. So for the lab guide, there is a PDF version. There's also a HTML version. If you download it and extract, so if you download everything as a zip and extract it, I find the web version easy to use because the hyperlinks are just better. Right.
Scott, can I ask you a question here? I downloaded the license, and I'm trying to do a have a look. Now I have one thing.
You got two M's in Cummulus there. So just tab it.
Oh, I can tap. Okay,
Yeah.
perfect. And then I do it. So the only I don't understand is how come we all have same license?
So there's not actually a license in the virtual version.
Oh.
It doesn't do a check.
Oh,
so this is you learning the process to
Yeah.
install a license.
Yep.
For the virtual image, which is what we're using here,
Yep.
no license. It's just free.
Okay. Alright. Now I understand. And those things, the PTMCLDL, that's
Yep.
telling me because when I downloaded the topology.
Yep.
So the topology.dot file, you're trying to copy it after I download the copy. That topology file is what I mean. Does it has the
So PTM is like a cabling verification tool. We'll talk about it later in the day.
Okay.
But it basically you give a switch a reference on what all its ports should be connected to.
Okay.
If it's connected to those things, pass, great. If it's not connected to those things, it tells you it's failed, and you can take actions based on that. It's really good for initial setup.
Okay, just updates on the leaf 01, leaf F01 on this one. The ones that got the topology doesn't put it to all other switches. Leaf 2 server.
No, you need to put it on there.
Oh,
That's normally something you'd automate.
If I want to download that OEA file, I can download from Cummulus, isn't it? Website.
Yeah. So
I
if
want
you
to
Google Cummulus VX, so you can download our virtual image in OVA. You can download it in QCal. You can download it as a Vagrant box. Like we have, there's a million choices you have.
Okay, and then I can use it. I can use the same lab. I can do the same lab there.
Yeah,
exactly the same.
Well, so it gives you the OS image, and then you need to create all the VMs and network them together. So you can do that in GNS3. You can do that in.
Oh, like this.
Yeah. So so each one of those would be an image.
Okay.
It's not one OVA that gives you the lab. It's one OVA is one image, and then you configure it.
Like similar config Cisco router. Oh, that's amazing.
like GNS3 or.
Yeah, that's amazing actually.
Can that be access the workbench? Can we just have
Yeah. We'll go caffeinate or. Want to get started again in this year?
How dry is this next section?
Oh, we're doing interface config stuff. So it's not the worst one.
Do I need cover to get through it?
We're going to go through the one.
Wow, this is very cool.
It's a free coffee machine out here, like good coffee machine. This is a catered kitchen. So the boys yesterday hit that up pretty hard. Well, it was free, so I think that was why they did it, not because they needed the caffeine. Yeah. That's hot chocolate too.
So that switch-D service, it's there on that VFX as well. Because you told me it's a proprietary. So in open source, when I download the VFX, the switch-D is also there. Okay.
Exactly like this.
Got a few mills, basically. I had a whole bunch of things I could have done at Cisco. There was there's a good company. Well, it is a good company. And I was doing reasonably well there. But like if Cummulus didn't come along, I probably wouldn't have. One of the things that frustrated me at Cisco, like you tend to see at big companies, is that I was limited by my function within TAC. I had the ability and capability to do more with Nexus from like a development and a product sense, but because I was in TAC, it was very, very hard to break out of that cycle. And in order for me to do that, I'd have to change a couple of times. And like, there's no way you ever get to touch everything. And Cummulus came along and it's like, you know, a small company, you know, we get good people in because of the contributions they can make to the company, to the product, to everything. And it's like, we're speaking my language. And it's been great. You know, when I started, we worked out of my apartment for a couple of months, got an office, moved offices, you know, did trade shows where no one never heard of us before, all the way through to, you know, selling a reasonable amount of kit to Telstra and, you know, Fortune 50 companies and all that kind of stuff. Went from, you know, minimum viable product to where we are now.
How much did Telstra spend?
We've done, so just this project, I don't know the raw dollar, but we've got six DCs where every top of rack, spine, super spine, like every networking piece is Cummulus on Dell.
Rough figures?
Ooh,
1 billion.
no. No, not on Cummulus. So you got to remember that the bulk of the cost is still hardware.
Yeah.
So like we of a switch is $20,000, Cummulus might make 4 out of it. Like the Cummulus component might be 4 or 5 grand. And then that's kind of what retail price is per switch for us.
5 grand switch.
Yeah.
How many switches? How many licenses do we buy?
Right now,
So I imagine we'll have probably a couple of racks in each data center.
no DC is smaller than 5 racks right now. Some of them are bigger, and this is the minimum viable product for the Telstra product.
Yep.
Minimum size. The tender comes out for 60 site full scale next year. But yeah, so every site has 2 top of rack leaves, at least 2 spines, at least 2 super spines, 2 border leaves, 2 border routers, and then a management leaf per rack, management spines, management super spines. So you're looking at sort of 40 switches a site at minimum size, 6 cells.
24 by 5.
We build an entire site in about 3 hours. So.
Use that coffee machine.
I need water.
So there is no any Wi-Fi here. I just put in my phone, but my phone doesn't work too.
Yeah. Run a battery.
Yeah, I know. 30% already. What's 50 on it?
See if I got an Apple cable.
I can thank you. Yeah, that would be great if you have.
I do not. I think. If it comes to it, just connect to mine.
Yeah, the others, they're all using the network, Telstra account with 50 gigs, so it's enough for.
Yeah, right. Yeah, I don't get
Let's
that.
see what happens.
Yeah, sure. I do have micro USB, USB-C, USB.
So we're just following the.
Yeah, just do lab 1. And basically, I
Lab
just want to see you
one,
guys. Just want to see you guys get onto the lab, install the license. That's the key things I want to tick off.
Yeah.
And then we'll start doing some actual networking config after some lab, after some theory. I'm going to get some water. I'll be back in a couple of minutes.
that one is verifying IT and verifying initial configuration.
So we need to finish lab 2 as well.
What are you drinking?
That's
Coconut water?
Coconut water, potassium. For hydration.
That one is to SSH to leaf 01. So are we going to install the OS everything or just
It's already installed for you.
cool? I'm already running out of battery, 30%. Can I connect to your
You want a hotspot?
hotspot? Yeah.
Yep.
You have enough
Yeah, it's
data?
Telstra anyway, so I
Yeah,
can
it was 50 when I came, now it's already 30. 1 hour.
13.
30. 30, yeah.
The battery.
Yeah.
That's why I told you get like this.
What do you want to do?
What?
that's
the?
good.
Oh my gosh.
Yeah,
That's a
How do you
This
use
is
the
a
fingerprint scanner on that?
iPhone.
Yeah,
You
it's-
don't have it.
I just want a hotspot then.
Just use the
This
iPhone.
is in the US company
Ah.
Zero Lemon.
Nah,
They make very good batteries for all the device.
hotspot you can.
And
That slides. Can I hold your phone?
yeah,
It's
sure.
a self-defense brick more.
Yeah.
My wife hits with this. She throws onto me.
Wow. Like, do you put this in your pocket?
I mean, I hold it in my hand.
So like when you're walking around, like is this in your pocket?
That's why I put it in my jacket.
Oh, in your jacket.
And you can't put it; it's too quite heavy.
Yeah.
But you can't see. Once I fell, and then it didn't happen to the screen. Otherwise, it's quite rugged
So,
case.
Yeah, I just got
All
and
That's it.
I dropped my Note 8 from like this high,
Yeah.
and
It broke?
internally the screen broke. They
Ooh.
replaced it under warranty, and then I got a brand new one and I got a case this time.
Yeah, the
So
rack
you
case.
dropped the phone and they replaced it.
You didn't tell
Where
me.
was that?
I have no visible external stuff.
Yeah.
Oh,
Like it was literally like a 10 centimeter drop.
yeah, my wife's got a note.
Hello, speaking.
Because they're quite nowadays with the warranty, they check everything.
Oh yeah.
They check everything, and then if they say no,
Yeah.
the finger, the main,
No, and so I took it to Samsung. They're like, okay, we'll get this repaired. Oh, we got no parts. We'll get you a refurb. Oh, the refurb's brand new.
Give it to me. Note 9 is
Have a
released.
Yeah,
Did you see Note 9?
I did, yeah.
But they have, I saw one feature in Note 9, something like, of course, wireless charging. There was another thing which was very nice.
Oh,
The Note 8 and the Note 9 are two different kind of beasts though. So the Note 9 goes back to what the Note used to be, which was much wider and a bigger phone. So
yeah.
the
I thought that was
Note
very.
8's kind of manageable, kind of.
Yeah. Although I think they did go very conservative on the battery on the Note 8 after what happened to the 7.
Yeah.
So,
Yeah, it's very bad. That's why I got this,
The,
you know.
the 9's actually got water cooling.
yeah.
I like very new phones.
Yeah,
But it's like $3,000, I think, $2,000. Yeah.
yeah,
You can get a laptop.
yeah, but I mean the laptop's lighter than your phone anyway.
But
Yeah, so I always have a backup phone, just because I'm calling customers and stuff like that. I went back to my 6S Plus. I kind of missed it.
any smartphone drains power.
I like the iCloud backup. Like iCloud's a really good integration, and I think iMessage is really good too. Especially because I'm a Mac user.
Everybody's got free messaging these days.
Yeah. That was a
I
pain.
just hate iTunes.
So in summer, what do you do with your phone? You're not wearing a jacket.
It's tough. I mean,
Where's the
but I used no, I did use Note A, but it was like I used like I charge it and then a couple of applications it gone. Like not even 3 hours, like 12%. I got irritated and I said that's all right. I don't mind carrying. At least it gives me a couple of days.
Too much Candy Crush, not enough work.
Apple does a very good job in the battery, especially Apple iPhone. But I don't know Samsung because of the, as you said, the one of the batteries. They had a big issue. They're very apprehended not to have much thing. So I logged into the website, Cummulus website. It has VX, KVM, Vagrant, VirtualBox, VMware. Oh, it has Vagrant to orchestrate. So I can't download Vagrant on my. I can, but how do I? Because
End of the day.
all right.
End of the day.
Because I'm going to download the VMware one.
Well, we've got traffic passing the same path. We don't expect to see that issue with.
He's got roped into a phone.
How many faults do you guys get a day? I mean, it not depends on the day, but if we average over a month, I mean,
The amount of stuff my group looks after is retarded.
Okay.
Yeah.
So, you're talking hundreds of thousands of boxes for very small thing. And then we also get added onto every sort of application. Because the network always gets blamed on us. We're also a customer escalation path and
for managed servers.
yeah. So all sorts of things. So our average queue at the moment is sitting about 50, 60 tickets.
For the whole team? And how big's the team?
I don't know.
Well, we're in a situation where
And so,
left is different to
do you
right.
have a backlog? Like you own a ticket?
I don't
or the
see
team
that
owns
we're
a ticket?
necessarily in a situation where
environment.
I don't see there any reason for a
queue management
recurrence duplicate capacity on Instagram 1. We haven't seen it on Instagram 2, and that's what we don't understand why we haven't seen it on Instagram 2. You would ideally we would get the MTU changed on router 2, switch 2, and then we can go, okay, we are normalized as far as we can.
Our workload's variable. It's depending on what breaks on the network. So our primary role is network monitoring and reaction to faults. So whenever something dies on the network, we
do nothing about it.
Our first in fix is the term I heard yesterday.
Yeah. So that's our primary role. But like I said, we have other responsibilities which can have to go on.
You guys are all out of Clayton as well?
Yeah. We're all these guys are support for 2 of the networks.
Have you seen the Clayton office?
No, I've been to Clayton DC, but never the office.
Ah, so looked like you're launching some rocket or something.
Yeah, that's what they mentioned.
Worst office space you've ever seen. Take away all the partitions and put a ridiculously huge screen on the front. That's what our workspace looks like.
So typically, I think there are fewer staff now. There's not much staff. There you go.
It's horrendous.
How's the noise level?
Not too bad because there's no one watching it. So when it was full, it was bad.
Yeah.
So now it's only about 10%.
Why? Part of the jobs.
People like you keep doing automation.
Yeah. Well, you learn it.
Cumulus, Juniper, every ST, you know.
If I learn it, I'll be tasked to go automate something and then nick it off, and then when it breaks, then you'll be there to fix it. Just like
You can come back as a contractor.
Why? So I can try and fix somebody else's botched attempted automation.
Do you think there's a lot of
saying any automation within Telstra, or if you had to follow on from it, you'll just see none of it's commented.
Yeah.
It's just like, well, why?
Yeah.
Why?
Well, I've written all the network automation for Telstra, so this project. So.
Is it heavily commented?
Yep. Well, like I've still got a whole bunch of commenting and documentation to do before I hand it off.
Mm.
And the L4 guys are own that, like the engineering guys. Apparently going to own that.
So I don't even know which platform this is going to get deployed on. Where it's
New platform.
Yeah, you say new platform, but it's going to be running something.
The automation, or the actual where the switches are.
Yeah.
So they're making a new platform for Telstra, which is the NFVI platform. So it's a generalized, open source based environment for predominantly right now network functions virtualization. So the Secure Internet project is going on it, but other BUs in Telstra are going to consider running on it.
I'm not across any of those projects.
Yeah.
First I hear about it is when you get some alarm. And I have to go.
Well, you're hearing about it now.
Certain tech leaders deploy things like that.
Yeah, explain the tech leads.
Did you work in Google? No. Because in Google Sydney, I'm sure they have a very big office like.
Yeah, down here, yep.
And all these, I see a lot of NOC corporations are, in the US quite a lot, but even then they're offshore a lot. But in Australia, you see NOC, but not, like maybe Cummulus NOC, Telstra.
Well, so Cummulus has support like TAC here.
Yeah.
But like we don't.
Is it offshore as well?
No, so it's one office in the US, one office in Australia. That's it.
Oh.
We do 24/7 out of 2 offices.
So I'm assuming it's going to have some sort of cross-connecting.
That's good. They had the mind to start in.
They also have, I think, some Juniper stuff.
Yeah. So this boot camp is obviously about getting you guys familiar with Cummulus. I think there's going to be like a full design session later on what the platform is, the components involved, from OpenStack and Juniper on the host to Cummulus on the networking, Ansible automation of it all.
It's just like it.
Yeah. Well, apart from the Juniper stuff.
So when you say Cummulus, these devices, Cummulus, are they going to be used as one part of it?
The spine leaf network.
Yeah, but this isn't going to be hardware review. It's not your hardware, right?
What was the question, sorry?
I said this won't have any hardware review. It's not your hardware.
So just like a server OS, once you put it on, it owns the whole box.
Yeah.
So we control everything on the box. We're not like a plug-in to Dell or anything like that. We own the whole thing. So
there's a faulty
hardware. It's a standardized operating system running on, it can run on multiple vendors.
Yeah.
But you will support the hardware, right?
Yeah. We have.
Oh, the Dell supports.
So, yeah, it's Dave from External Network Ops. Dell will be responsible for the RMA of the physical hardware.
Correct. We can do it as well.
Is that the question you're asking?
Yeah. I assume that's the question, right?
Sure.
So we will work with Dell on the back end, so we're single throat to choke, like Dell can be a single throat to choke for Cummulus stuff as well. We have a B2B relationship in the back end, share tickets, things like that. We can open an RMA on your behalf. And we sort of bypass entitlement and stuff like that. Like they assume we've done entitlement. Likewise, we assume they've done entitlement before they throw it across the fence for a Cummulus problem. So all those B2B relationships are there, and to make it a seamless experience.
I have a quick question about the leaf spine. I mean, obviously it's removing the layer to loops, and there's no STP configured. So leaf spine. So you still configure it on the leaf, like the BPDU guard, all those toolkits, right?
Yes. Down to the host, you still do BPDU guard, port admin edge, stuff like that. Yep.
Okay, but not read. I mean, the main. So why do we?
Why do you want to do that? Leaf to host? one, so if you connect a switch to it, it's blocked.
Okay.
Like if you connected another switch to a leaf,
Yeah.
it'll admin down the port.
Yeah.
And two, you want to go instantaneously. You don't want to go learning, listening, forwarding.
Yeah.
Or blocking, learning, listening, forwarding. You want to go straight from blocking to forwarding. So those are the two things. PPU guard to stop if a switch comes on.
Yep.
Like that, and you want to go instantly to forwarding.
And you mentioned in the class about VXLAN.
Yes.
We heard this term quite a lot and about creating tunneling.
Cover it right at the end of the day.
Oh, right.
It's
If we can. We're missing one.
Come back to
Cummulus providing lunch?
No.
No way.
Let's go back to SD. They didn't give us much either.
Juniper provided lunch, didn't they?
No, they didn't. Red Hat did. Red Hat is good.
Oh, yeah.
Pretty good. Yeah, great.
Was it done by Red Hat themselves or DDLS?
DDLS. I mean, the Red Hat hosted the training, the venue, the catering, everything's done by DDLS. It's just like renting.
The Shrine 100 was like right next door, so it's nice walk. Great.
How many staff are there in Cummulus, Australia? Like
8.
8? Whoa. I thought when you say Cummulus is the US and Australia, I thought the numbers.
24/7 support for the sunrise.
You only need 8.
Well, so that's 8 across all functions.
Whoa! So how big is the building? Like just one office?
Our first office was about the size of this room.
Whoa!
What year was that?
2015, 16. And then last year, about this time, we moved into a larger office. Now we have a table tennis table.
So,
I am the reigning champion.
So you must be the training. You're the training expert across Australia or New York.
So I am the professional services guy.
Okay.
So I do deployment, training, consulting, design, automation. I get thrown into it.
There's no HR, nothing like no managers.
We got support. We got me. And we got sales in Australia.
You're the man that sells the dream.
No, I don't sell the dream. I deliver the dream.
Oh.
Okay. Is everyone on the phone back in? Tony, Yvonne, Ekram? Yep. Yvonne?
Doesn't go well, coffee. Does.
Close enough?
Yeah,
good. Yeah, awesome. Thank you. Cool. And everyone can still see the screen, right?
Of course.
Even people on the WebEx? Lovely. Okay, so let's move on with some actual networking config. What we do want to start with, though, is something we call NCLU, or the Net Command Line Utility. So you guys have all done the Red Hat training now. How did you configure things? You edited a file, you restarted a service. You edited a file, you reloaded a service. All those methodologies and all those ways of doing things are identical on Cummulus. You can definitely do it all that way. But for someone who comes in with a pure networking background, never touched Linux, that's really daunting. You know, that's an operational challenge that you need to get your head around. It takes a long time, and we recognize that. So what Cummulus has on box is NCLU, which is a command line, tab complete command line for Linux. And basically it's there designed to, one, enable a networking person to achieve everything, but also teach them the underlying file changes that we're making as part of that. So we can use NCLU to do all the interface level configuration, or the routing configuration, and some, but not all, services configuration. We're building more into it every release to try and cover everything on the box. But it's not there for everything just yet, but everything we do today, it will be covered in there. So from here on out, we're going to show the net command as well as the end file state as to what you should be putting in the file. Everyone has their own way of thinking about it. Everyone has their own workflow. We don't dictate. We let you guys pick. Personally, I find some things easy with NCLU, and some things I've just got muscle memory doing it the old way. And there are some things that I'll do different ways. And it's all really up to you how you feel it, your comfortability with editing files and running commands and looking for things. But for everything here on out, we're going to show the both ways of doing it, just for reference. So, like I mentioned, one of the things that Linux is a little bit more difficult for is tab complete. Everyone loves tab complete, question mark on all the traditional OSs, right? It's super helpful as a network guy to have that. We now bring that into Linux for you. Net tab, no question mark, just tab. And what we do is we can stage configuration, commit it, abort it, and roll back. It's very similar to the do not methodology of stage some commits, check it, push it, and all that kind of stuff. There is a CLI on Box, and that's what we're going to be showing. There is an API that you can use to run net command as well. I've also got some built-in examples on how to achieve certain things, configure MLAG, configure BGP, things like that. So what we've got here are the basic interactions. Net add, we're going to add or modify configuration. Add a route, add a VLAN onto a trunk, modify a VLAN list, something like that. Net del is remove configuration. Net commit is we're going to, so net add and net del, put things into the commit buffer. Net commit actually commits and makes those changes live on the box. We can roll back with net rollback. Net pending is show us the changes that we're going to make. So normally I do net add something, net pending, I'm happy with it, net commit. Or net del something, net pending, net commit. Net abort is if we're not happy with the stuff in our commit buffer, throw it away and we can start again. Some other things that we've got there, net help. This is great. You can do net your commands help and it'll show you all the other possible completions from there. Or you can do net help the thing you're looking for. So if I'm looking for a particular BGP knob like add path, I do net help add path and would go search all the possible commands for add path and show them to you. Net example is show some examples of things that we have. Net clear, clear the counter, clear BGP neighbors, etc. And net show. And net show is a big one we'll talk about later. For ops guys, the examples are completely extensible. So while we have examples on how to configure MLAG, how to do this, you guys can add your own examples into there for how do I verify that this is working, how would I do X and Y and Z specific for your use case. And that's all available for you on Box. So I'm not going to walk up to the screen because you guys can't see that remotely. In this particular case, we're going to put a static IP address onto the ETH0 interface. So we're going to do net add interface, ETH0, IP address, then the IP address. That is the command to do it. And what we can see here is that in the Etsy network interfaces file, this is where all the interface configuration lives. These are the file changes that we're making. So we're deleting this line in red, and we're adding these two lines in green. This isn't us colorizing it. It actually colorizes it on Box for you. It's pretty handy. It does have some recommendations if you get something wrong. It knows the valid parameters for all the commands, and it'll tell you what it thinks you need to fix. We can also do some really, really complex range statements. So we can do 7-9, so it's 7, 8, 9, 12, 15, 16, 17, 22, using a range of commas and dashes to get that sort of language out. And of course, it's got some guardrails to stop you doing things that you've already done or would be disruptive or just not valid. There is a config file for NCLU, and it doesn't have a command to make it work. It's sort of chicken and egg problem there. This is in Etsy. I say Etsy, ETC, whatever you want to say. EtsyNetD.conf. By default, only the Cummulus and the root users can run these commands, and you can break that down to users with show, users with edit. So if you have an external authentication service like LDAP, you've got to make sure that LDAP is taken into account when you do this. as well. One of the other things it does is it shows you historical commits, what changes were made. Every time you do a commit, it takes a snapshot, and you can see the commits that have been done with descriptions and the time and everything like that. We can show specifically what changed in every commit, and we can get full history and the commands used to get that over time. Every single net command on the box is logged. So not only do we see the changes and the commits in netd-history, in varlog netd.log, every single net command is logged. It's a really great tool for auditing. And of course, with these things, you can see how the config on the box changed over time on the box. Okay. We do have a lab for this. It'll get you familiar with net, but we're going to see more of it throughout the day. We're going to do this a little bit later. We'll just do labs 2 and 3 together. Okay. So like I mentioned, net is there for you to use if you want to use it. There are some workflows that I personally do with there, but you'll find your own way of doing it. No one's going to dictate it to you. Pick what you want to do. Any questions? Cool. One thing, just so you know, I don't go through them, but there is an appendix to most slide decks here. So if you have downloaded the content, there are some other things that you can look at further down in those slide decks. Okay. Let's look at how we configure interfaces. Okay. So we talked about the console port and the S0 port. We need to talk about the rest of the front panel ports. The front panel ports, the ones that are behind the ASIC, are called SWP. Okay? SWP stands for switch port. A lot of people say swap or swip, whatever works for you. Again, we're not really fussed. These are the things that are enabled by the license. They are not keyed on speed. So on some vendors, you've got GE, XE, all those kind of different speed differentiators. There is no speed differentiator. No matter what speed it is, it's still called an SWP. It's 1 based, not 0 based as well. So the first port is swap 1. One thing that isn't covered here that Telstra do have is they have 4x10 breakout cables. I don't know if you guys have ever seen them, but you have a 40 gig port, one physical 40 gig port. You can actually turn that into 4 physical 10 gig ports through certain cable types and optics. When that happens, so we broke out swap 1, you would have 4, swap 1 is removed, and you have 4 interfaces in its place. Swap 1 S0, swap 1 S2, swap 1, 0, 1, 2, 3. Okay, so that is what happens when you physically break out a port. Yeah, that is 0 based, just to be confusing. We have logical interface, sorry?
Other hardware, so all the hardware is standardized. So are they labeled 1, starting at 1 on the hardware?
Yes. Go back 5 years ago, no. Now, yes. All the open networking switches are 1 based, really well labeled. And of course, like Dell has their own OS they can put on these guys as well. So.
Yep. If you're going to start at 1, makes sense for the hardware to start at 1. So.
Yeah. We have some logical interfaces on the box as well. So we talked about the physicals. We've got a loopback. We all know the purpose of the loopback, router ID, stuff like that. Bonds, link aggregations, lags, port channels, ether channels, yada, yada, yada. And bridges. And we'll cover bridges at the end of this section. It's a different logical interface. It's a little bit different conceptually on Cummulus and some of the other incumbents. Okay, so like we mentioned, Linux has a few ways of doing things. The ways that we're going to talk about from here on out are configuring the interfaces file or interfaces config. We can do that with a text editor, or we can use the net commands to edit it and make those changes for us. Okay. Just some intro to some of the other commands. Net show configuration commands. A bit of an interesting one. Looking at the files that we currently have, what would be the commands that we would use to get to that state? So if this was our file on the right, Etsy network interfaces, if we do net show config commands, the commands that would be used to generate that file would be net add loopback LO, net add interface E0, IP address DHCP. Just so you know that that capability is there. This is kind of as close to a copy paste show run as we can get, or as we get. Just keep that in mind. There is no true show run capability that we have that you can copy paste and put back in. That'll make a bit more sense as we get through this. Okay, so if we look at configuring the front panel ports, and anytime we're configuring a physical interface, we're going to do net add interface, and we'll see how that third keyword changes. If we're configuring interface, net add interface, then the physical interface name, chuck an IP address on there, chuck the L1 characteristics on there, and you can see what that is there. In Etsy Network interfaces, you have a stanza or a paragraph per interface. So we'll have the ETH0 paragraph, the swap1 paragraph, the swap2 paragraph, and so on and so forth in that file. Loopbacks, like we know, loopbacks are used a lot in routing for router IDs, for BGP peerings, things like that. Within an operating system, it's also used for local host functionality. We're polling things internally, having some inter-process communication. It's done using that local host address. Where we were configuring physical interfaces before, we are now configuring loopbacks. So we're doing a net add loopback, so that keyword change. LO, that's the loopback name, and that's fixed for us. IP address, the address. Likewise, in Etsy Network interface, we have its own dedicated stanza. A loopback interface is signified by inet LO. inet loopback, sorry. Bonds. Okay, so like I mentioned, a bond in Linux has various names depending on the networking vendor that you're working with. Cisco call it a port channel, other vendors call it an ether channel, NIC teaming, lag, things like that. But conceptually, it's where we take two or more physical interfaces and put them together to operate as one logical interface. You may want to do this for additional bandwidth, you may want to do this for redundancy. There's a range of reasons that people tend to use port channels and bonds. For Cummulus, we only support two modes. We support LACP, port channel mode active, in Cisco speak. In Linux speak, that's mode 4. And we do static port channeling mode on from a Cisco perspective, so no control plane over the top. In Cummulus, we have no limitation on how few or how many ports you can put into a bond. You can put all the ports on the switch in a bond if you really want to. No limitation there. You can also do odd numbers and still get good flow distribution amongst the members as well. It's a hash, modulo-based hash, if you're interested. Okay, so here's how we would configure a bond in Cummulus. Unlike other implementations, bonds and interfaces in Linux are keyed based on name, not by number. So where in a Cisco you might have port channel 1, port channel 20, that number is the identifier for it. In Linux, it's a named identifier. So in this case, we're going to create a bond called James, and we're going to give it the bond slaves swap 49 and swap 50. Okay, and that's the configuration that we have there on the right, rendered by that. Okay. One of the things that normally comes up about this time is someone goes, well, how do you set an interface description? You can definitely do that with us. It's called an alias rather than a description. But what we often find is that when you are creating name-based interfaces, you put the description in the name. It's kind of logical sense. So in this particular deployment that we're doing, the bonds are the server that they connect to and their purpose. That is the name of the bond. We don't need to put a description there because the name itself has the description in it.
Show bond James, that will show the port channel.
You do net show bonds or net show interface James.
Can you change the name once it's created?
No. Just like changing a port channel number, you've got to take it down and bring it back up. Exactly right.
I'm assuming you can have numbers as the names as well.
Yes. Pure numbers, like net add bond 1. Yeah. We'll give it a go. So some of the other things that we can configure for bonds, by default, we start in fast rate LACP. That's a PDU every second. That's the default for us. We can turn that down to slow by setting the bond parameters appropriately. One other thing that we do is we have a feature called LACP bypass, and we definitely use this in this deployment. That basically means, say you had a server that wanted to pixie boot, but we're configured for LACP, we being the switch. We're not going to bring up the bond until we receive LACP, right? LACP bypass means that we'll let you transmit and receive traffic, but as soon as we receive an LACP packet, we then become a full bond. So it enables hosts to pixie boot without an OS, without LACP. Once we get LACP running, we're a fully working LACP bond. So 2 ways of displaying the bond status. The first one is Netro interface bonds. This is like your show port channel summary. You can see there the name of the bond, whether it's up or down. The aggregate speed, you'll see this is a bond of 2 1 gig ports, therefore it's a 2 gig port. We can see the bond members there on the right and their individual status as well in the brackets. We also have the capability of saying, hey, switch, show me what interfaces on my switch, which physical interfaces are members of bonds. And that's Netro interface bond mems. And so it's just a flip on that logic, show me which physical interfaces are in bonds rather than show me the bonds themselves. Just so you know that capability is there. You can also see remote host, remote port there. So we automatically aggregate LLDP or CDP information into this output as well. Just so you can come there and sort of get all the information you want in a single command rather than having to run multiple commands together. To get more detailed stuff, and this is obviously the more Linuxy way of doing it, we can look in the Linux file system at procnet bonding, then the name of the bond. If you cat that file, you'll see some more detailed LACP information. Mostly you only go in there to look at the LACP system ID of your partner. That's the only time I've ever had to use it. There is a reserved name. We reserve the name peerlink for use with MLAG, which is the next topic after this. So it's only going to give you limited capabilities for peerlink because it is reserved. Everything else you'll see the full gamut of configuration options. Okay. Questions on interfaces?
Yeah, just a stupid question.
Sure.
You do have licenses for 1 gig, 40 gig.
Mm-hmm.
So why do you need to configure interfaces saying this what goes in battery and stuff like that? Isn't it automated or something like that?
No. No. So the license is purely a financial transaction thing for us.
And
Can they send minimum links for the bonds?
You can. Your min links is a valid thing we can do, yeah.
in Cisco, there is layer 2 and layer 3 port channel, isn't it? So this you can have both.
Yeah, so it all depends on how you configure that bond as to whether it is, but we do both L2 and L3 bonds as well, and bond sub interfaces and all that kind of stuff. Okay, so we're going to talk about bridges. This is conceptually a little bit different to some of the other vendor implementations. The term bridge from back in the day, it's a device that will switch Ethernet frames for you. Not a hub that just bridges it. Lost David? And he's back. And he's gone.
Alright.
That's fine.
I'm here, you just don't need to see me.
I was watching you put your money in your wallet earlier.
So bridge, in CCNA speak, is something that will forward Ethernet frames based on the MAC address. That's a concept that we continue to use here. In a traditional Linux sense, you would have one bridge per broadcast domain. That doesn't scale particularly well. So now we can have multiple VLANs in a bridge. We have a VLAN aware bridge, and we'll sort of compare and contrast these things as we move forward. For us, we only run RSTP, so no per VLAN span tree, no MST. But of course, those by protocol definition do interop. And of course, we can .1Q tag things or double tag them or have them as access ports. Okay, so on the left is the VLAN aware syntax, which is what we're going to be very familiar with. And on the right, and I'll talk to the right first, is the traditional way of doing things. This is how bridging on Linux hosts, Linux bridging works on hosts and how it's configured. Basically, we create a broadcast domain. Let's look at the third one, BR-VLAN 3. We create a broadcast domain, and we say port 1 VLAN 3 and port 2 VLAN 3 are going to be in this broadcast domain. So you can see there the swap 1.3. So we're saying port 1 VLAN 3 and port 2 VLAN 3 are going to be in this broadcast domain. I can do some really funky stuff, and I could say port 1 VLAN 3 and port 2 VLAN 666 are in the same broadcast domain. And that's really the application for this traditional mode. On a host, it doesn't really matter. They've got specific resources and CPUs and all that kind of stuff. But on a switch, that's really the use case for a traditional bridge. What we tend to use now for scale implications is the VLAN aware bridge mode. And what we have on the left is ports 1 and 2. They're layer 2 ports, and they're trunking VLANs 1 to 200, and they have a native VLAN of 1. That's what the P bit at the bottom means. So both of these two configurations achieve the same thing. We could have 200 broadcast domains, and we can manually control the interface tagging, or we put them all into one bridge, and the bridge controls all the interface tagging. Conceptually, are we good with that? Okay. We pretty much exclusively use the left-hand side. So the only use case for traditional mode is really fine granular control on VLAN tagging, and you can do some funkier layer 2 policing and stuff like that on there. Okay, so for the VLAN aware bridge, it's basically like the L2 information of the switch and the VLAN database all rolled into one logical construct. By default, all ports that are members of the bridge, which you can see in the bridge ports list, inherit the characteristics of the bridge. So keep that inheritance word in mind. Okay, this is how we would define it with NCLU. We do net add bridge, the name of the bridge. The name bridge is reserved for a VLAN aware bridge. You can give it another name, but it then has to become a traditional bridge. We enslave the ports. We put the VLANs on there. This can be a comma-separated list or some of those range statements that we saw before. And we set a native VLAN. PVID stands for primary VLAN ID, not private. Okay, we don't do private VLANs. And if we do decide to do private VLANs, I'm quitting because I hate them. Okay. On top of that, we can define SVIs. You notice how we see the keyword change again. When we did net add interface, we're configuring physical interfaces. Net add loopback is loopbacks. Net add bridge, we're configuring bridge. Net add VLAN, we're configuring VLANs. In SVIs, we can put IPv4, IPv6 addresses. SVI capabilities are pretty universal across the board. That's what the standard looks like in Etsy network interfaces. Notice how we don't have to specify IPv4 or IPv6. We're smart enough to figure out what address family that's from. Okay, so looking at the config that we have there, ports 1 and 2, we've got VLANs 100 and 200 there. That is all we need in the Etsy network interfaces file to achieve trunking those VLANs on ports 100 and 200. So by default, all ports in the bridge inherit the characteristics of the bridge. So ports 1 and ports 2 are members of this bridge. This bridge has VLANs 100 and 200. They're going to trunk VLANs 100 and 200. It's straight up inheritance. We can see STP is on, again, that's on by default. Let's introduce swap 3 into the equation now. We've got a new server that's come online. It only needs VLAN 200. So we add it into the bridge. By default, it would trunk VLANs 100 and 200, inherit that configuration, but we've got more specific configuration on its interface. So we inherit the characteristics and then we apply the more specific things over the top. So this guy will still have a native VLAN of 1. It will still have spanning tree on because that's defined in the bridge, but it has a more specific trunk allows list. Okay. We do access ports as well. We do that by specifying bridge access, then the VLAN ID. This means that anything that comes in untagged on this port will be put into VLAN 100 within the switch. And of course, we've got a whole gamut of STP commands that you'd expect. Admin edge, auto edge, BPDU guard, BPDU filter, all those things are there and available for you as well. breakout ports. This is how you would configure them. So this is where we're going to take a 100 gig or 40 gig connection, break it out into 4x10 or 25 gig, 2x50, etc., etc. Net at interface, the physical interface breakout, and you can see the capabilities that we have there as well. The config file for this is etccumulusports.conf. Okay. When we do this action, it is disruptive, just like everyone else. We need to restart the ASIC and completely reprogram it to make this physical layer change. So when you do this, all the ports on the ASIC will go down, switch D will restart, and everything gets reprogrammed with this new physical makeup. For us, everyone else has to reload the box. For us, we can just restart that daemon.
So the whole switch will
So like on a Cisco line card, you've got to restart the whole line card, or a single AU box, you've got to restart the whole box. For us, we just restart a process. So it's normally a 15-20 second thing. All the interfaces will go down, all the program in the ASIC gets flushed, then it will come back. So you just got to be aware of that. You want to kind of get this right beforehand whenever possible.
Yeah, I didn't see 10x10 in there.
There is no 10x10.
Good.
Yeah, that they basically improved serialization technology that doesn't make sense within the physical capabilities of the switch anymore. Okay, let's look at config verification. This is where we're really going to start using net show. Trying to find IP information, bridging information, all that kind of stuff. In Linux, there's a whole slew of commands that really you need to go look at multiple places to find, and put it all together yourself. Net show is where this is really, really helpful. Net show, interestingly enough, started out as a support engineer going, well, I'm sick of troubleshooting this crap. Like, where is everything? I've got to remember it all. I've got a huge chunk of notes. I'm going to write something for me that'll help me aggregate it all together. And that's what really started this project. As a support engineer saying, I'm going to develop something for Cummulus, wrote a few basic Python scripts, and that's how it all started. You can see all the things that you've got there. It's all tab complete. And you can always use net help to find what you're after. Net show interface is my favorite command on the box. Favorite net command on the box. It is like show IP at brief, show interface, and all those things kind of rolled into one. You can see IP addresses, VLAN configuration, mode, speed, neighbors, all that stuff in one command. Very, very helpful. So net show bridge VLAN is like show me the VLAN database, what VLANs you configured on the port, whether they're native, so on and so forth. In this particular case, we can see bond 0 has VLANs 10 and 20 trunked, and VLAN 1 is the native. So PVID again is the primary VLAN ID or native, where swap 2 is an access port in VLAN 10. Net show bridge max is your MAC address table. You can see which VLAN, which port where. Tab complete to break that down per VLAN, per MAC, so on and so forth. Given this is just Linux, you can also obviously pipe, grep, sed, awk, cut, all those kind of things on top of all these commands as well, if you want. If you weren't using net commands and you wanted to see some of that configured in runtime state, we have if query. Basically, if query will go into Etsy network interfaces, try and render it for you and make sure that the configuration is valid, and show you what's configured. If you want to see that for all interfaces, if query -a. Net show bridge spanning tree is like a show spanning tree brief. And then, of course, you can do it on a per interface basis as well. Right here, you've got the mode. You'd see route forwarding, alternate blocking, all those kind of states in the top right. And one of the other things we tend to look for if we're troubleshooting L2 problems is the number of TCNs that we've received or transmitted, and the route IDs and things like that. So this is the full lab topology, and we're going to continue to build this out over the day. It's actually missing server 2 and server 4 from this diagram, so we do have more servers in there as well. What we're going to slowly do now is continue to build out features and functionality onto this topology till we get a full spine leaf layer 3 network. So lab 3, we're going to start configuring some basic L2. We're going to have servers in access, trunk it across between 2 leaves, and go server to server as a ping. So what I'd like to do now, unless there are any questions, is lab 2, lab 3.
have to finish lab 1, then
Yeah, you need to take a license.
You did.
you have a license. Already installed.
Um, okay, so just to sort of set my plan out, want to do these 2 labs, cover MLAG content, lunch, MLAG lab, routing lab. So I'm looking to kind of break again at about 12:30.
So use that alias in the interface description.
What's that, sorry?
So that alias is used as an interface description.
Yeah.
So I'm just pressing the tab again. It's giving me the sound. Hold on.
Oh, so if you you're using Putty,
Yeah.
If you go up the top somewhere, there should be enable, like disable bell. So change settings, bell, and then I would do visual bell, so it'll flash the window. Third one? Yeah.
Oh. Oh.
Yep.
Yeah, that's right. Thank you.
I'm just going to grab some water. Anyone else want water? Or not refill or anything like that?
Thank you for that. Thank you.
There we go. You guys done yet? Yeah, we're done.
Almost.
Description. What does it do?
So it doesn't net commit, but then if you look at the net show commit history, you can like it'll have a name, whatever the description you give it.
So you just
Otherwise,
only-
it just
you
says
save the changes that we done.
no. So net commit saves the changes,
Net rollback.
and then net show commit description followed by the description will just it'll show you in the history that I did this for this reason because this change request or whatever you put there.
Super user do.
Yeah, that's
So who are we gonna make
carry
it?
lunch outside. It's like,
You want to roll back?
Yep. Call up Cummulus and say, hey man,
you know,
So I'll be completely honest. I did bring down, or I was supposed to bring down a whole bunch of stickers and like little squishy rocket turtles. I don't know if you've seen our logo. It's a rocket turtle.
so if you had it for his t-shirts, you
Oh, that's nice.
But I left them in Sydney, so I will get them sent to you. They will come. But yes.
You can send it to me.
Free
I'll send-
advertising.
Yeah. Well, Toss's already bought it.
Enable REST server. GUNI con. I don't know what is that. GUNI con. REST server.
So if you remember how NCLU also has an API, it's a REST API, and that's a web server.
Oh, this is a REST API, the Northbound interface. Oh, that's different.
Yeah, yeah. So you can use it to do net commands on the box. What are you trying to complete?
That's your interface.
Oh, okay. So if you tab after interface, it's going to expect an interface to be shown to you. So next show interface like show interface or show interface.
I'm trying to tap that interface. It's saying pipe. But I have 10 fingers, so don't worry about it.
So let's roll back last, goes to the last one. You want to go to 2 before.
I don't remember.
Yeah, you do net rollback the commit ID.
Oh, you do it.
Something like that, yeah.
So, yeah, in that table, they're all numbered.
service. That's service.
Just server.
Similar.
It's
different
you've got
tab.
servers. You should be able to tab it. So if you just go back to
Service. So that's service.
okay. Yes. Gotcha.
That's an extra t-shirt.
No, the lab guide is based on a version 2 before the actual switches are running. So
I think I did doing something wrong here. I kind of it is case sensitive, but I did type it correctly.
Yeah, and what happens? No URL specified. You need you need a space there.
In the HTTP?
No. So yeah, right there. Put space. Yep. There you go. So if you look here, we're saying run this curl with these arguments, and then this is the command space. This is the URL we're going to run at. So curl is the command.
Yeah.
Post is the REST action. Minus U is the username password. Minus H is the web headers we're going to give it. So we're saying we're going to give you JSON. The data for that is the JSON formatted command, and that's the destination where we're going to do the curl. Do the request.
Okay.
We have to sort the command completely, yeah? Instead of the exit, if you put exit, it doesn't go. We have to type exit.
To leave the box?
Yeah, not EXI. You have to say show, not CHO.
Yeah, so if you type EXI and hit tab, it probably completes to more than one thing. Let me double check.
It's one letter.
And sometimes very
One letter for many years.
Put I instead of include everything or press tab.
if I quickly go to my own, my login instructions. Actually, I've got everything on the box. Let's use that. Control D.
Control D. What's that one?
You guys ever use Control R? That's my favorite.
Control R.
What's that? I can't remember what it does.
Control R is go back through my command history and search.
Oh yeah, the guy told us.
Yeah, that's my favorite.
It's easier than Cisco.
Hmm?
It's easier than Cisco for a first line.
Yeah. That's Control K is clear screen.
Everything gets press tab. Press server, press tab.
The lab guide says it's not REST server.
Press server dot service.
REST server dot service.
Service. The first tab.
But then there's no output.
There's no output.
There's no output.
After restart.
We're trying to enable the REST server.
Yep.
Yes.
We should say like created system.
So if it's already enabled, you won't see it again. So if you do system CTL status REST server dot service
System.
CTL, so instead of enable, you're going to put status. System CTL status REST server dot service. Status REST server tab.
Talk to yourself.
So you can see it's already enabled. Yeah.
So if it wasn't enabled, that would be disabled. It's enabling to start that service. So I think Red Hat used the same thing as well. So this is standard Linux way of interacting, starting, restarting, enabling services. Enable means turn this on, restart. So if you reboot the box, this service will start automatically. If something is not enabled, it won't happen.
Windows in this computer. Do something.
Yeah, actually, I completed the second thing as well, the curl.
Yeah.
And that basically showing me the JSON
JSON output, yeah.
JSON output.
So if you can move on to lab 3 and
Yeah.
do the basic VLAN and trunking config.
Sure.
What's number 12 and 13? What we going to do? What's the purpose of that?
12 and 13. So lab 2.
Yeah.
He's talking about the JSON output and the web output.
So if you remember in the slide deck, you could use the net commands on the box on the CLI, or you could run them via an API. You're enabling the API and running a request to that API.
So we see the same.
You'll see the same output, yeah. Yeah. Feel free to skip that one.
May I ask you? May I ask you one thing? This JSON, the 13th one, the output it's showing already. It's like they are all default JSON output, swap swix and all those things. So
on the command line, if you run show interface, you get the nicely human printed output. If you do show interface JSON, it prints it as JSON output for you.
So show interface.
And hit enter.
You mean on the leaf-o one, isn't it?
Yeah, do net show interface.
Hold on 1 second. I'll log SSH to leaf 01. Net show interface. Yeah, I'm able to see that.
And so that's nice.
Loop
You can
back
read that,
in the
right?
internet,
And
and
if
then
you do net show interface JSON,
JSON, isn't it?
yes.
Yeah, the same thing.
The content, like the actual output is different, but it's showing you the same thing. One's just easy to read as a human, one's easy to read as a computer.
Yep. So it automatically converts the whatever. I mean, when you manually configure, it's automatically updating the JSON script, JSON code as well.
No, that's just looking at the file
Yeah.
and then converting that to JSON.
Yes.
So someone can, include that data into a script or monitor it or any of those things. It's not actually existing as JSON data. The config files are JSON data is just a way that someone can come in and monitor it programmatically.
So I'm proceeding with lab 3 now.
How many key strokes? I say for life.
Just wait till you see command a controller.
Done.
Yeah. So do you want to know how geeky I am?
Yeah, I've used it before.
You want to know how geeky I am? My caps lock key is now a control key. Because that's so much easier to do all the control stuff. because you're like trying to do control. You're like, oh yeah.
Stretch.
Yeah. So I never use caps lock. So my caps lock key, so like Control A to go to the front line, Control E. It's all much easier, and I don't have any RSI
But how did you change that?
hacks. It's in system preferences on Mac. You can do it on Windows too. Just keyboard preferences.
Do you want us to continue that for as well?
Please do Lab 3, yes. So by the time we start MLAG, I want everyone to be able to ping server to server in VLAN 10.
You said that the system actually highlight the output red or green, yeah? But here in the lab,
Your terminal has to be right for it.
okay, so it depends on the terminal.
So you've got to have Xterm 256 color or something like that. If you do on your system echo $term all in capitals, which is where you need a caps lock key.
What's the password for leave02?
So it's the default password, just Cumulus with a capital C, Linux with a capital L,
that one. Okay.
exclamation mark. But I just exit to the out-of-band management server and then go into leave2.
So it's automatically.
Yeah. So we push the SSH key from this server into the switches. You mean key binding? So we've got there's out-of-band management server as a private public key. And if you put the private key into the authorized host file on the switches, it lets you in.
What was it? Cummulus Network?
Cumulus Linux. Just exit to the out-of-band management
So
server.
did you put the private key into the management server?
You put the private key, you put the server's private key into the switch's authorized host file.
That's why it's allowing automatically without asking it.
But if you go leaf1 to leaf2, leaf1's key is not in leaf2.
That's why it's asking the password, right?
Cumulus with a capital C, Linux with a capital L, exclamation mark.
I didn't ask.
So from the server to the switches it won't, switch to switch it will. Cumulus with a capital C, so CUMULUS, Linux with a capital L, exclamation mark. Just do it all from the out-of-band management server. Just easier.
Loopback has predefined default config, and make sure you should not delete that loopback.
Oh yeah, don't delete the loopback. Some stuff still works.
So the default is there, and the one that I added is also there.
Yeah.
Thank you.
So by default it's there with 127.0.0.1, and then you add your network specific one.
::1, that's IPv6, isn't it?
Correct. I'm sure everyone in networking is saying there's no place like 127.0.0.1 t-shirts. I don't know if you've seen any of the INE t-shirts about the routing protocols. They're pretty funny. Let me see if I can share this. Can one of you guys hit share on the VMR box for me? Can you share? No, the big white thing.
This is cool.
Yeah, that one. Sharing box. Right.
Yeah, share the front one.
Can you share on the VMR box? Right. The big white thing.
Yeah.
These are the I&E t-shirts.
Straight out of EIGRP. No. Oh my god.
Is that what they're giving us?
No.
No.
This is one of my favorites. I've got 99 problems, but a Switch ain't one.
Can we claim this in tax as uniforms?
Oh, yeah, you can.
Yeah.
Until they audit you.
Oh.
Gotta wear one of these t-shirts.
Yeah, networking is easy as 011011.
DNS is a real old. Yeah, the trainer is also very knowledgeable, very funny. Yeah, it's very good. So when I add the bond 0 for sleeves SWP 4950, I'm getting a message 49 and 50 is is not a physical interface on the switch. That's right. Yeah, just ignore it.
No, it shouldn't be saying that. Which one are you doing?
Switch.
Oh yeah. I know. You know what? You know why? I know where I made a mistake. Instead of going to the leaf 1, I was in the OB management.
Ah.
That's why.
We do like three.
Just do like 3, yeah.
I made a small issue here. If you, what happened was, when I tried to do a net commit, it's saying commenting. No, I know why. Because I typed this one also on leaf 1. So how do I get to the point?
What do you want to do now? So leaf 1 is already configured, right? Do you do net show interface bonds?
That's what I do it on left 4. What do you want to say? Student, I said left 4.
Bonds.
Left 4.
Yeah. So it's already there and configured. So now go to leaf 2, exit.
And then get it to that. Yeah, because I saw the message.
Yeah, so it'll tell
ignored,
you.
No, ignored, comment in.
Yeah, because you've done it. You're trying to do it again, there's nothing to change.
Oh, yeah.
Right? So you see how it says on leaf 1, then go to leaf 2.
Net show interface bonds. I can see that.
Optical level.
These are virtual switches. So no, but yeah.
I don't know the other switch.
You get the full DOM.
Bond MEMS.
If
What's
the
that?
optic has it built in.
Bond MEMS. What's that?
Wouldn't that be standard on your fantastic new hardware compliance?
So you know how some of them have policy you can only put their optics in there. We got to do service on support transceiver. We don't believe in that. We believe that you can put anything in there as long as it conforms to standards. If it conforms to SFP, QSFP, 28 standards, then it works with us. And so a lot of people save 90% of their optics by going open networking. And you know, in a full fiber data center, you spend more on optics than you do on switches. Excluding huge chassis-based systems, like, you know, if you have LR optics everywhere, you're paying $3 grand an optic, but a switch that costs 20 grand, you put 5 of them in there, but you can go down to fiberstore.com, pick one up for $500.
That's what I was going to say. Yeah, if you go to cheap Chinese ones.
So there's a lot of people that's what I
just like cheap NTP cables.
Yeah, so some people do it, they get burnt because they don't comply, they're a bit shitty. Some people go that next step up and they're pretty happy then, like, you know, Finisars, your Avagos, and fiberstore.com, they're generally pretty okay. What we do, if we jump onto the Cummulus HCL, I'm going to unpause the WebEx. I'm not checking work emails anymore. If we go to cumulusnetworks.com, that's the WebEx.com. Hey, I've got a bookmark in mind. .hcl. cumulusnetworks.com/hcl. Hardware compatibility. So we do have a pretty large optic test bed as well. So against this model, which is what we have here at Telstra.
Yeah, I was assuming that they'll be just Dell DOMs.
No. Interestingly, Dell ran out of optics.
Ran out.
Because everything's 100 gig, and they're just
can't keep up.
Nope. And so they bought some from Mellanox. Mellanox ran out. They bought some from I can't remember where now. Yeah. So these are the ones that we have personally tested. We do sell some as well, like we rebrand some of the ones that we've tested. But these are all the 100 gig optics that we have personally tested and continue to test with every release in this model switch. And then, so that was the 100 gig switch. We've got the 40s, the 25s, and
Did I see some Cisco?
no. So this is the Cisco equivalent with the same basic info. And then we've also got some other things, a new product that we can't talk about in the bootcamp. How do the Facebook switches? So Facebook made their own switches, which we also support. We're the only go-to-market partner for their switches. But you know, they had that buying power. They said the same thing. They built their own switches, made by a company called Sticker, and use them internally with their own OS called FBOSS. They also made a data center interconnect platform, which is they call Facebook Void, and we're the only go-to-market partner for them as well. But basically a 100 gig switch, 4 by 100 gig port switch, and then 4 200 gig Adver optical DWM muxes in front. And so, you know, you get 800 gig across many thousands of kilometers. That's a good DC edge box, data center interconnects and stuff like that. This one's a cool fun one. They're pretty expensive, though.
Yeah.
But you no longer need a dedicated optical box. It's kind of the whole point. Like, they're like, we don't need a big optical box just for one purpose. We want to have an audio device and an optical box in the one thing. So they built it and they open sourced it. Yeah.
So that'll integrate with other WD.
Yep. Yep. So Adva come in on the top and you can use the Adva abilities and stuff to come in and control specifically the weapon stuff. We did a pretty big announcement. Cummulus Voyager. So this is Voda Euro, not Voda here. Yeah. VHA, TPG. Maybe. It's got to get past the ACCC first, right?
Yeah.
So, the understanding is the gate of getting rid of the fiber optical and then using this one. I mean, fiber optics to transform optical network.
So
when you said cheap, cheap.
So in order to do optical network,
So rather than connecting your switch into like an app drop mux into an SDH, sorry, WDM, it'll just plug directly into the WDM. Using its own. How do they do the channel management between the? Does it work? So you said it was an open source.
The hardware is open source. Adva have a daemon that they put on Cummulus Network, and then they control the wavelengths.
Control the wavelength, yeah. So it does all the filtering and things internally in the box.
I mean, these
channel frequency.
I think so.
Yeah.
I've not personally played with one. They're pretty rare.
What? New training. SEN.
How's everyone going with Lab 3?
I'm on step number 12. I've made it as an access port. I'll finish it shortly.
Georgie boy. And Abdul. That's going Abdul. Abdul's good.
It's good. It's even when you retype the command, it says that it's already done.
4 day course. Friday's obviously an
ODA. Some of the achievements of the trial were optical commissioning, modular power frequency to 200 gig. So that box is like 60 grand.
That's true.
By comparison, yeah.
So yeah, that's cheap.
That's USD.
It's still cheap. Well, 200 gig WDM, that's
I want to get started again in a few minutes on the content. Do MLAG, eat some food, come back, keep building stuff onto our networks.
Whoa, this lab 2 goes on for pages. I still need some time. Okay.
If you're on 12, lab 3, you're pretty close to the end, I think.
I think I still need a good couple of pages, 2-3 pages, more than that.
It gets to 20, but it's pretty much all verification from there on out. Yeah.
I want to crack it so that it remembers.
From the people on the phone remote, can I just get an indication of how you're going with Lab 3, please?
Done.
Done.
Thank you. Waiting for that last one.
I see you. One. Just send me one every day. Hey, man, since you got to accept it before you can send it again. With I forgot yesterday. Sorry, just insurance. You should get onto the network to fix that. EDM. I still can't get it. I don't know why. I was nearly holding the F5 RMA to get the evidence. Even though I set it up to do everything else in the EDM. I still got to use the 5-year emails. Because you're supposed to be using that instead of the old Nexus. I can use
It's
it.
an RNA. You shouldn't need any of that stuff if you come in by cable.
No, that's what I'm saying. I should be able
No,
to.
let me think that in standards.
I still have to authenticate through a proxy when I'm on the cable.
So,
You know, like auto detect is enough for that for me.
sure how to work.
Are you a smoker? What is... Oh.
And then
Yeah.
I think too many girlfriends. No.
As soon as he jumps back in, we'll get started.
so you said you're across the installation.
Yeah.
That's just implementation. Yeah.
Yeah.
I'm assuming they have one of the DCs that exhibitions.
No. Clayton's and Leonard's.
Have you been on site there or?
Clayton's and Leonard's, yes. They've also done Weymouth, Wollongabba, Wellington. So Wollongabba's Brisbane.
Yeah, well.
Yeah, and then Weymouth, South Australia. And
I had the same one in Sydney today.
that place is weird. It's like stepping back in time. Like I feel like I'm in like a communist Russia, like military installation.
It's that
Something
way.
that's
That's why I came it's like
1822.
standing on the road. Okay.
Yeah.
Do they make you get out and walk the whole way?
Yeah.
And you're not allowed to take any boxes.
Well, I mean, everything was wrapped and stacked by Dell.
Oh, okay.
So, the server platform they chose, something called Dell DSS. They're basically assembled in factory racks with sled-based servers. So they're three in an RU for compute, and 2 in an RU for storage. And it's pre-built, pre-cabled in factory, and they just roll it in.
Oh.
Yeah.
So it's just already done off the truck and it's already mounted.
Mm-hmm.
they just get plugged in the rack and power.
An external network. Yeah.
Yeah.
And so they put the switches in there straight away to tell who. Everything else is rack and stack for them.
How do I do show version on leaf 01? Do I want to know?
Net show system. Net show version.
This Cummulus is deployed and is in service now. What's the name of the platform?
NFBI. Network Functions Virtualization Infrastructure. So NFV, this one's still waiting to find, is basically the concept where you take something that would ordinarily be done by an appliance, like a physical appliance, and then do it on standardized x86 compute. So, if you had a firewall as an example, you'd have one firewall, your hardware box, but it can only scale to a certain point. If you need another one, you need to buy another one, and you have all this spare capacity until you've got no capacity left. You've got to buy another one. All those things are really expensive. If you can put that on x86, you can really scale it up and scale it down with more VMs or less VMs or more resources, less resources, very, very easily. So you can use that one platform for really high bandwidth intensity by scaling it out in a centralized data center. Or you can go chuck it in an exchange site and have like 1 or 2 VMs there. But if you needed more bandwidth there and more of that function, you just put it out there. So that could be firewalls, load balancing, IP telephony stuff. Because it's x86, you can do pretty much everything with it. And that's the way a lot of the service providers are going.
That shows spanning tree? Scott, net show spanning tree. How do I check the spanning tree?
Net show bridge spanning tree.
Oh.
Net help.
Net show bridge spanning tree. Really? There's nothing there. Net show. Oh yeah.
Bridge STP. Sorry.
Oh, it's just STP.
So how is that different to SDN?
NFV?
Yeah. Because the way you just described it is basically what SDN.
So SDN for me, and again, it's all what it's
which you did explain at the start.
Would be encompassing of all the connectivity, not just to that virtualized function, but between the virtualized functions as well. And that's what Contral's really providing. I don't know if you guys done the Juniper.
Yeah, we done
training. And so those guys are doing the networking between those virtual functions. And so they'll say, well, this flow needs to come into here, needs to hit this function, then it comes out of that function, we need to get it to this thing next, and that's what they're holding there, and that's the controller based.
That's really the controller controls the whole.
Yeah, exactly. So they do the host to host, very fine grained flow mechanics, where we do a big lots of data, smart. Okay, let's move on now that we've got everyone back. Let's talk MLAG. Who's heard of MLAG before? Any other names you know it by? Not stacking. Good question. So VPC is the big one. That's the Cisco implementation. MCLAG is named by a few vendors. We are going to talk it as a general concept as MLAG. Okay. So functionally what it is though is where we are taking 2 switches and 2 switches only and making it present like a single switch to a connecting device. So we'll have 2 leaves talking to 1 server, and there's a range of reasons why we might want to do that. One is redundancy. We've got device level redundancy now. If we had 2 ports connected to 1 switch, that switch dies, you're stuffed. With 2 switches, you can tolerate a half loss of that and still keep running. The main difference between MLAG and stacking, MLAG, each switch is its own independent entity with its own control plane, and it makes its own decisions. In a switch stack, you have 1 control plane that controls them all together. You can't individually log into each of those switches and do their own thing. It's one thing. So in this case, you have not just device level redundancy, but operation OS level redundancy as well, because they both maintain their OS. If you had a stack, the OS goes down, the whole stack goes down, and you still got that fundamental problem. No one does switch stacking in DC. Switch stacking is great for campus because you're only ever going to have 1 link out, and so extended star designs, but in DC, where you've got high levels of redundancy, that there's really no point to it. And the industry is really standardized around MLAG. So we can do MLAG in a couple of ways. We can do a host MLAG where we represent as a single switch to a single device, or we can do a switch-to-switch or back-to-back, double-sided, however you want to call it, MLAG, where a switch pair connects to another switch pair. They all think they're connecting to one device only, but you have a four-way redundancy there. Some terms that we're going to use throughout this sort of glossary table you can go back on later. CLAG-D. So Cummulus, when we first did MLAG, worried about getting sued for using the term MLAG as our protocol. We know how that kind of plays out in Vendorland now. So we decided to call it Cummulus lag, CLAG, or CLAG like the glue. So that's the term that I tend to use, CLAG. So CLAG-D or CLAG daemon is the actual software process on the switch that controls all those MLAG functionalities. We have the peer link, that's the data path between the two switches forming an MLAG. We have the peer link sub-interface. This is where we're going to exchange all those control messages between those MLAG peers. We have a SysMAC. This is the unique system identifier for a pair of switches. We have a backup IP, which is a secondary keep-alive mechanism. And we have, obviously the bonds that go down to the host or to the switches. So what we need for an MLAG is obviously two switches, no more than two switches. It's two switches and two switches only. And we need to have a link between them. We want it to, or it must be a bond. We recommend two or more links for obvious reasons. It must be LACP mode. Okay, it doesn't matter what speed it is. We don't mandate any of those things. But, it should be a dual member bond at least. When you're doing network design, one thing you've got to think about is sizing the peer link in the event of link failures, and we'll talk about that more when we get to the failure scenario. So minimum 2, you may want more depending on your traffic flows. And for every dually connected host or bond, every CLAG or MLAG that we're doing, we need to have a unique MLAG or CLAG ID. From a command perspective, we need to know a few things ahead of time when we're going to go configure this. The interfaces, what interface is going to make up the peer link. We need to identify a role, whether we want a switch to be a primary or a secondary. Again, this becomes important in failure scenarios we'll talk about later. We need to know that SysMAC we're going to use to identify this pair. We need to know the other switch's backup IP. And we need to know, obviously, what interface are going to connect to hosts. This is the command that would commands that are used to bring up everything we need to do. So it's going to establish MLAG, establish a host bond, and trunk all the VLANs on it. This is something I definitely do with NCLU. We'll look at the full interface config file of this later. It's a little bit convoluted and hard to remember. So this is something that I prefer to do with NCLU if I'm manually configuring boxes. So to break it up, we're going to do net add CLAG. Notice that keyword change again. We're doing CLAG. Adding a peer. The SysMAC is the unique MAC address that we're using between these two devices. Interface is the interface that's forming the peer link. This guy is LeafO1, we'll make him primary. And the backup IP is the ETH0 interface, of this case, of the Leaf2. We tend to use the ETH0 interface for this kind of thing. We're going to add some VLANs to be trunked. And then we're going to create a dually connected bond 2, with the CLAG ID of 1. It's like a VPC ID, same functional concept. You'll notice that the first command is pretty long. If you were configuring this on a console, it is pretty hard, and we'll see a way to mitigate that in a second. LeafO2, the configuration is pretty much identical. We're only flipping the role. This guy will be the secondary. Obviously, the backup IP has to be Leaf1's address, not Leaf2's, but everything else is identical. So like I mentioned, that's a really long command. If you're doing this on a console, we've all had this happen where it starts wrapping over itself and it looks really weird and you don't know where you are anymore and you can't backspace. It just gets really weird. Because this is just Linux and it's just bash, we can do commands over multiple lines. So in order to break this up, just add the /, hit enter, it'll drop you onto a new line, just continue doing your current command. Really helpful if you're on a console. Okay. This is the actual config that's generated by doing those commands. So we see the bond called P-link there with the two slaves, 49 and 50. We then have that layer 3 subinterface, P-link.4094. We've got a point-to-point /30 network there, and we'll talk about what that's used for in a second. We've specified the backup IP, we've specified the sysmac, and we've specified a priority. Our default priority does exist, which is 32.768, if you don't specify it otherwise. This is the LeFO2 config. Again, it's identical, except we're flipping things that are unique to this guy. This guy is going to be .2 on that /30. Its peer is now .1, and the backup IP is LeFO1's. By doing that command, we also automatically create a bridge. So we create a VLAN aware bridge by default. The P-link is included in the bridge ports, and all those VLANs that we did in the VLAN command are then added onto the bridge as well. Yeah, one thing to keep in mind, if you do manually configure this, often people do forget to put the P-link in the bridge ports. The NCLU command, because we have that flexibility, is like a macro to do all these things for you. But if you're manually configuring it, just make sure you remember to add P-link. Then we've got the two bonds down the bottom that connect to the host. Server 01 is the name of the bond. And you can see that the CLAG ID for server 01 is 1, CLAG ID for server 02 is 2. This is the server-side config. So this is an Ubuntu server that we're going to have in the lab here. You notice that the config looks really, really similar because it's the same. The defaults are slightly different. You need to specify them on Ubuntu where you don't on Cummulus, but this is the config that's there on the server side. Okay, so we've looked at the config. Let's look at what happens when we actually configure MLAG, how we bring it up. The first thing we're going to do is across that P-link subinterface, we saw that /30, P-link 4094, we're going to bring up a TCP session between the two. There's a reserved Cummulus TCP port that we use, and that's what it's there for. Over that TCP session, we're going to negotiate who is the primary, who is the secondary. In that command, we said primary, secondary. That just basically controls the role, the priority that's configured there. So primary means priority 1000, secondary means priority 2000. In a tiebreaker, if they're both the same, the lowest priority is the same, then the lowest MAC address wins. Across that P-link subinterface, we're going to continue to send keeper lives, and we're also going to send MAC address updates as they come through, VLAN updates, IGMP updates as they happen. We're going to sync that state between the two boxes on that subinterface. We're also going to do keeper lives along the backup IP. Questions about MLAG. We're going to do failure scenarios at the end of this after we talk about gateway redundancy. But from a layer 2 perspective, MLAG is all good. So let's talk about VRR. A lot of vendors, even though that the MLAG devices are active forwarders, they still maintain an active standby control plane using things like VRRP and HSRP. So they artificially make it so that even though this is a HSRP standby, I'm still going to be an active router on that segment. But when you think about it, if they're going to be active, what's the point of maintaining a control plane? You know, these guys will always be active forwarders, and that's kind of the mentality that Cummulus took into it. We do VRRP, don't get me wrong, but what we tend to use, again in sort of 98% of deployments, on an MLAG setup is VRR, Cummulus Virtual Router Redundancy, and it is an active control planeless gateway redundancy solution. Put the same IP on both sides. No control plane, nothing like that, it's statically configured. And that's because MLAG is always going to be an active forwarder. So in this particular case, both these guys in this VLAN have the address 10.1.10.1. If a VM happened to ARP to the left, LeFO1 will respond with the MAC address for that. And likewise, if someone ARP to the right for that gateway IP, they both respond with the same MAC. So whichever way we go, we get the same result back for an ARP entry, and both of these guys will route if packets are destined to that MAC address. Okay. So one of the things that MLAG does is we do not learn MAC addresses on the P-link. We don't do that traditional ingress learning that you would do on a host-facing port. anything that is learnt on leaf 01 is synced with the CLAG ID over to leaf 02. So the one thing you always want to avoid is if a packet were to come into leaf 02 and it's destined for VMA, when the MAC might have been learnt on leaf 1, we don't want to send it across the peer link and down. We want to send it directly down. If the link is up, we always want to go direct. We never want to go across the peer link. Okay, so that's why we sync the MACs across, and we don't do MAC learning on the peer link. If you did MAC learning on the peer link, you end up with a whole bunch of MAC flaps, and there's some other things to prevent loops in MLAG that come into play here. Okay, in order to configure a VRR address, we're going to configure that on an SVI, so net add VLAN, the VLAN ID, IP, address-virtual. There we specify the MAC address that we want for this IP and the IP itself. This config is going to be identical on leaf 01 and leaf 02. Okay. We recommend that the VRRP MAC range is used, just because it's a well-known gateway MAC. You can pick whatever MAC that you want. Some people pick the Cummulus OUI, but VRRP MACs in Wireshark and just in people's brains go, oh, that's a gateway MAC. So it's nice and simple there. Okay. Let's talk about what happens when we start losing links in MLAG and how we tolerate it and the failure scenarios. So in a normal operation, like we just talked about, MACs are synced between the two. If a packet's received on leaf 02 going to server 01, it sends it straight down. It doesn't send it across the peer link. You know, we're in a really good state, and all that data is synced across. If we did happen to lose one of those dually connected links, we're going to make a change here. Leaf 01 goes, well, my side, I can't get to it anymore. The link's down. I am going to send it across the peer link. So that's a software change. It says, my local link's down. My only way to get there is now via leaf 2. Update the MAC table, send it across there. Leaf 2 remains unchanged. Okay. What happens then? What happens now in a different scenario if we were to lose the peer link? So in the peer link scenario, we have no way of getting between the two devices. Someone's come in, cut the link, or whatever has happened. The peer link is down, but that backup IP, that backup mechanism for keep alive is still responding. So the primary knows, and this is where the roles become important, the primary knows that secondary is still alive, the secondary knows that primary is still alive. We just don't have connectivity between the two devices. In that scenario, the secondary will take down all of its dually connected links. So the one thing we want to avoid is, say the peer link was down and the secondary was still up. If a packet was hashed by the server to leaf 02 and it was a broadcast packet, like an ARP request going to another host, that's never going to get to the end destination, especially if it's solely connected to leaf 01. So we make sure there is only one possible communication path. The peer link goes down, the secondary takes down all of its dual connected interfaces. Okay.
The preemption is enabled, isn't it? So when the first scenario.
Yeah, the CLAG roles are preempted. Okay, so let's assume in another scenario the peer link goes down and the backup IP stops responding. So this could be the current primary's crashed, or someone's just come through with a really big hacksaw and shut all the links between the two. In this scenario, like power failure is the most likely, right? In the event that the primary stops responding, peer link goes down, the backup IP stops responding, the secondary then asserts itself as the primary, and all its links stay up and all the traffic goes through that way. If the secondary lost all its connectivity, like the secondary went down, the peer link goes down, the backup IP stops responding for the secondary, the primary just continues hanging on, right? But if the primary goes down fully, secondary asserts itself. From a software perspective, what happens is peer link goes down, the secondary does immediately a rapid connectivity check. It sends 5 pings, basically, along the backup IP. If none of those respond in 0.3 of a second, it asserts itself. It never takes its links down. So there is always going to be a tiny little outage whenever this happens. It's sub-second though.
So if you've got, say, a contractor going into the exchange, cut cables one by one, That
never happens. Yeah.
So he cuts the peeling first.
Yeah.
So LeafO2 shuts down again.
Yes.
And then, because he's a quality contractor, he's going to turn off the power to rack 1. As soon as that backup IP stops responding, does that automatically enable all the interfaces on LeafO2?
I believe so. It won't do that rapid connectivity check because that happens as soon as the peeling goes down, and it knows it needs to assert itself immediately. I think it would be a slower timeout in the event it was this goes down now, this goes down a minute later.
So, in regards to the operating function of LeafO2, does it go? How does that work?
How does it assert itself as primary, or?
Yeah. So the connection between server 1 shut down, so it shuts down.
So yeah, that will be down because we're back in this scenario, right? Except flip the roles.
Yeah.
Yep.
And so.
Yep.
The other box goes down. How does it know?
Because we're constantly, while it's up, sending backup pings across the backup IP.
So you're in that mode there.
So as soon as the
leaf 1 loses power.
So as soon as
we go from this.
As soon as the backup IP stops responding, leaf 2 goes. All right, everything's down. I
now have to assert myself as primary. So it does a rapid detection straight away as the peeling goes down, like that really quick sub-second stuff.
Yep.
If it happened a minute later, it's going to wait for a more traditional timeout.
And it goes, I need to bring everything
up. How do we verify MLAG state and net shows CLAG? In this diagram here, we can see the peer is alive. So the peer is alive means we've got communication across the peer-link sub-interface. Okay. We see our priority role and unique MAC in the top and the peers in the second line. The NCLU command to create MLAG automatically creates that /30 that we have there. We can say that's the 169.254 range, but you can obviously change that if you're manually configuring it. We see the backup IP and whether it is active, and we see that shared sysmac that's there. Further down, we see all the CLAGs that are there, what the bond name is on our side, what the bond name is on the other side. They don't have to be the same, but make it the same. And then if there are any consistency things that were wrong, you'd see it there in conflicts. Okay, what we will do when we come back from lunch is configure MLAG between the two devices. First thing we're going to do is pure L2, so continuing everything in VLAN 10, bring up dually connected bonds and all that kind of stuff. Then what we're going to do is we're going to configure VRR, put server 01 in VLAN 10, server 02 in VLAN 20, do some inter-VLAN routing across MLAG. So I talked about it, but I didn't say what it's used for. Does anyone want to have a punt at what this system MAC is used for? We have to specify it. It's got to be unique. What do we think we use it for?
Virtual router.
Not that one, not for the MLAG. The CLAG system MAC.
CLAG system MAC.
This CLAG system MAC here.
That's for
using that for VR.
Not quite. That's the VRRP range that we use. Either someone on the phone dropped off or was going to say something. The drop off? Okay. So the system MAC is used for two things. It's the spanning tree bridge address. So when these guys are participating in a layer 2 network, they're going to send spanning tree BPDUs. If we were connected to a single device and we were sending 2 different BPDUs, it's going to freak out. So we have to send the same BPDU so they know they're connected to a single device. Also from a spanning tree perspective, the other thing it's used for is the LACP system ID. So LACP is used to ensure that our bonding config is right. That's the function of it. And the way that we do that is we check the packets coming in and say, is this system ID the same on all of my links that I'm receiving? If it is, great, I've got an awesome bond. If it's not, something's wrong, I'm going to keep down one of those links. So this is how the mechanism and the MAC that is used to trick the rest of the network to saying we are a single device.
Something else left?
Hungry for lunch? Or there's an outage.
You said it.
Those L3 guys, I tell you. Okay, so that's it from me. Let's take an hour, come back 1:30, or come back early if you want. Do labs 4A, 4B.
okay.
1:30 back here.
Safely there.